ഞാൻ മുന്നിൽ കൂട്ടോ കോച്ചാ മുന്നിൽ കൂട്ടോ ഒരു പോ മാറി മാറി
Okay, I didn't properly introduce. So each team will be awarded with $2,000 for your driver support. Okay, next one is the third placement in teleoperation team Inventec from Taiwan. Okay, the next one. The second placement in teleoperation, Team Apollo, Tsinghua University. Okay, next one. The first placement in teleoperation, Team ICR Locomotion from University of Science and Technology of China.
You can stand there.
Okay, finally, we have the IROS 2024 Quadruped World Challenge Champion, the first placement in autonomous, Team Wangsai, Zhejiang University. Okay, so this is all, and next year we have at least 2 events ready. I think we will go to the Atlanta in May, and also is it Hangzhou, right? Hangzhou in October. So please remember this event and then come back with your upgraded technologies. Okay, thank you. So let's take all picture together. Thank you. Oh.
Hello everyone. My name is Akos Chen from Unitree Robotics. I'm the co-founder of Unitree. From the year 2022, we started to sponsor the QRC competition. We are very honored to work with the organizer, with every people. And in the future, we will try our best to support us, to serve us. And we hope that next year, IROS and also IROS in Hangzhou, we can meet again. Thank you very much.
ബാറ്ററി വന്നാലും നിങ്ങളത് മുന്നില്ല സൈഡായിരിക്കും എഫോൺ ഏതാണ് കുഞ്ഞിക്കാറില്ല ആ ഫ്രണ്ട് എടുത്തേ
When those cars are out, it makes it more exciting. The original release carries much more, so it looks faster. So that's going to be more exciting. Car, you should park properly. Isn't that fine? Ooh, another alert. Ooh. Bonus point for parking properly. Alright. Okay. So that should conclude the 7-day first round. Actually, it's a 6th round of the whole tournament. Okay. Let's take a quick break. Let's wait for the leaderboard to
Everyone ready?
get up there.
Load up. There you go.
Everyone ready?
The scores are not yet in, but
Starting 3, 2, 1, go! This time there was no struggle. Neither vehicles, they started smoothly.
still Zion in the lead.
Let's hope to see that we see something different this time. Both teams are going consistently
We
smooth.
are going to be starting the next round.
We have collisions. KUF team will have to reset the track. KUCs will be driving.
भैया
Can you please have something to help these teams? And we have a overtake here. KUCs are driving smooth. Force IDH helping out KUF team. Going in the wrong direction. Have a reset. We have another overtake. Can you please cheer the Force IDH guys for helping out the KUF team? And we are on the go. The cars coming very close to each other now.
So hello, what you see behind me is the F110 Autonomous Racing Challenge. This challenge is for autonomously racing your vehicles as fast as you can. Yesterday we had the qualifications. There are 6 teams that have qualified. And today what we'll be having is head-to-head races of 2 teams at a time. Every step of the competition, 1 team will be eliminated and the winner will proceed towards the subsequent round of the competition. And we have this race bracket set up so that eventually we will go down to a point where we have 2 of the best competitors who will compete for the first and second place. And then we will have another round where we will be competing, the teams will be competing for the 3rd place. And all of this will take place in the next few minutes and hours. So the whole idea of this competition is to come up with algorithms that can now efficiently race the autonomous vehicles at their limits. These vehicles are 1/10 the size of full-scale vehicles, which are similar to F1 cars, where the objective is of racing. And what we have as an objective here is, through this competition, we are promoting robotics and robotics research. We are promoting the spirit of competition that can help these students to now come up with unique algorithms, unique strategies to race their vehicles autonomously while avoiding static as well as dynamic obstacles. And this way, it's like a fun way to learn as well as explore and research in the field of robotics. So what we have as a tagline here that says is, these vehicles are 1/10 the size, but this creates 10 times the fun for the competitors and the participants.
They have to take this probe and insert it into the terminal block here, and then they're going to wrap this cable. It's actually a good demonstration about how tricky this could be. Insert it back into its rest and press stop. So that's what you're going to see the robots do autonomously, and we have our jury in front of us. Thank you guys for joining us. I'm going to attempt to name everyone. Professor Aline Abu Schafer from DLR, thank you for joining us. Actually, we have a slide here. We're doing it live. Okay. It seems to be running back. Could you get to the jury slide, please? Back one more. There's another jury slide. Dr. Fabio Bazzanolio from University of Zagreb, thank you for joining us. Dr. Fares Abudaka from New York University here in Abu Dhabi, is that correct? And then we also have my co-organizer, newly professor, Abdallah Sukir, who's going to be at Technical University of Munich and is now moving, I think, to here in Abu Dhabi. So congratulations on that. So what's going to happen next is we're going to go through and we're going to have 3 presentations. They're going to have 15 minutes to give you a demonstration of their complete solution. The solution will include a solution to the task board with their robots, but it will also include a bring your own device challenge, which is the challenge to take the skills they develop on the task board and port those to an object of their choice. And we chose objects that are in the circular economy for recycling. So you might see some objects that the teams will bring out, and they'll show how they can demonstrate that the solutions they developed over the last 30 days was not only relevant to the task board, but for other tasks in the real world. So jury, please keep an eye out for 3 awards. We have 3 awards to give out today. The top award is the fastest, the first award is the fastest solution to the task board. This will be recorded by our clocks. And we have the second award, which is the best transferability demo. This is taking the skills they learned on the task board and moving them to another object. The third and top prize will be the most versatile solution. So making sure whatever solution that they come up with is not relevant only to this competition, but it could be used beyond to new tasks for the future use. And so this is what we're going to see. The 2 prizes have $400 attached to them, and the top prize we have $1,000 to award. So we'll be doing an award ceremony at 11:30 on the stage right behind you at 11:30. So without further ado, I'm going to go ahead and turn it over to the teams, and we'll get started. Hello, welcome. This is also Dr. Yudi Presetio. He's our local chair, helping us with all the organization. Thank you for being here. Great. So I would give you guys the screen, and you can begin your demonstration. Sydney, could you come, please? And during this time, it's a bit informal, so jury, I would invite you, please. These are collaborative robots. We actually have a very exciting debate between the UR company and the Franca. So you'll get to see the best of the best in the collaborative robotics on the market going head-to-head in this challenge. So I invite you, if you cannot see, you can come up and look closer. Just please stay away from the motion of the robot. Sydney, could you please man this camera? Make sure it's pointing at the action, that'd be great. Thank you. So the teams will have roughly 15 minutes to present to you their solution. They're going to do a task board solution, they'll bring your own device, and they'll give some words on the screen. So maybe briefly introduce yourself. Or if you want, I can introduce you guys.
So, hi everyone. We are Team Design Learning Research, and I am... You have to be very loud. My name is Sun Haoran, and this is Guo Jie. We are all PhD
sorry?
Does this come up?
Yeah. Let me just keep it straight. Yeah. They came all the way from China for us today. So here we go. We'll see their solution. Maybe you can see here the screen from the robot there as well. So each time the team finishes a task, there'll be a light that blinks on the task board to confirm that the task has been successfully completed. And there you have it. That's a good time, right? I'll just read off the time here. The time is 46:95, 46 seconds, 95 milliseconds.
Yes, we can actually be quicker. This is only the 50% of the speed. Yes. So later on we'll turn to full speed. Yes.
I can get another pen.
Hey, how are you? Sorry.
Hi. Do you guys have some pens?
Pen.
Maybe offer it to the jury there.
For the jury?
These guys here. Does anyone need a pen? No, it's all done. Okay. Sorry, thank you. What?
The certificates.
Ah, perfect. Okay. Please go ahead and try again. Yep.
robotic system setup. So we have URC robot, and we also have this one in our lab. And we also design our own movement kit. Okay. And we also have
You guys ready?
As ready as well.
I know. Nerves, huh? Is it working?
It seems like it's
Yeah, just get ready to go, huh?
We're thinking about moving it after the first trial, but I guess that's just up to the jury.
Up to the jury. I mean, you want to show that you're perceiving. That's what's more powerful of a message. But make it work, please. Yeah, do your best. Yeah, no worries. Yeah. Are you guys done?
Yeah.
No more demo.
Yes. No more demo.
Okay.
We can just fix in the box.
Then I would ask the other team to get ready.
Okay.
If that's okay.
Okay.
Do you guys want to try one more time, or you're okay?
I think it's fine.
It's okay.
Yeah.
Okay. Okay. Then great job, I would say, huh?
Thank you.
Okay. You guys should set up.
Is it the precision, then it's okay, right? Nothing else. There is no another trial?
I asked them if they want to do one more, and they said no.
Okay, so you are happy with the first, we took the first one, right?
The first one, yeah.
Classes, right?
Yeah, yeah.
Actually spend about 3 to 5 hours into it. Yeah. You gotta make it slowly until it's stable. All of it to make it work. Maybe like one or two days we
microphone would have really been helpful.
Your pen, I forgot.
I'm very, I can be loud.
Your pen, I need to get one. I will, you know, yep.
All the team has the CAD model.
No, we do not provide the CAD models to the teams. They generated the CAD model themselves. Yeah.
So it's your choice to go with this.
They choose to use the CAD reprojection models, and that uses how so they basically perceive a few points, and then everything is transformed off of the coordinate frame from the box, and they use the CAD model to generate that. Yeah. Mic is still on. Do you need it back?
Thank you.
Roger. Start. There you go.
2, 1, and go. Start your really fast. And very quickly. Finding the vehicles at turns.
Okay, so that flight was completely anonymous. The drone flew itself all the way through the course. And I can see some PhD students here, some college students, and if you think you can build an autonomous drone, or if you want to try and build an autonomous drone, this is a competition. So you can register an 8-hour for free, and the qualification is going to be in November, the actual wage is going to be in April, registration is free, and if you somehow manage to win, you will find through of $1 million. So make sure you follow the group of the show, and you can to see what it is.
Both of these cars are driving really great. They are showing here consistency and speed at the same time. That's a really great technology. We have 9 laps for Zig Ultimate, 9 laps for Speed Area Support as well, and Zig Ultimate finishes first. Really cutthroat competition.
And if you're in some school going through, you want to get into the drone, you want to do an easier as well. All the details that you will need is over there.
So what do you think, guys? Will it be the same again, or will it be this time?
There's a DC simulator there that you can get on Steam
Yeah.
PlayStation as well. And you can get a first-hand experience of how it is to fly an FPV drone. So, just to tell you a little bit about that drone, right? That is an autonomous drone. It has an NVIDIA OS compute unit on the top.
Yeah.
And it has an NVIDIA OS compute unit on the top, and an Intel built system on the bottom.
The final race, these teams are considered one of the final. First race, one second place on the leaderboard.
That's how the team is telling me that they're ready, so let's go for it.
Let's begin the race in 3, 2, 1, and go. Both teams have shown their knowledge of the competition. They have clear consistency.
Okay guys, take out your cameras because we go in 3, 2, 1, take off.
Not struggling at all. Again, they are giving me some moving on areas and more, but they have been some ways as well. Not letting the school area. Not letting they can't even catch up to those. Both the cars are really fast on the straight, but not slowing down too much on the bottom. You can see here oversteering, the vehicles are being pushed to their limits here. Be as fast as possible.
Okay, so that was the autonomous drone. If you use this drone running, we have 2 more flights of the autonomous drone.
Can you please
And
share
then
both of
after
these?
that, I'm going to be flying this DCL drone in this drone. Also, I can see a lot of students here. So if you guys are interested in learn more about drones, head over to the DCL group after the show. And there will be people explaining to you about a STEM program that teaches you everything you need to know about drones.
Jin Ultimate has managed to win this race. They have secured the first place on the leaderboard. Surya has for second, and Dhuri and scored by PhD has secured the third place on the leaderboard. User applause for all the teams. It was a great performance throughout the competition.
Okay.
Can we please have all the teams
because
So that was the autonomous drone.
because it's
Now, I told you a lot about how the autonomous drone works. That's not really told you what I'm going to do. So I'm going to be flying the DCL drone.
wider.
It has an FPV camera in the front and a video transmitter in the back of it. So it sends me live video feed from the camera to a pair of goggles that I'll be wearing quite soon. And I'm going to be flying the drone looking at that, using that controller over there.
Yeah, because here is nothing now.
And remember, this is all different from the autonomous drone because that thing is doing everything on board. There's nobody giving any commands to the rest of the drone is flying except for take off and land. That's it. Now, I'm repeating this once, but I'm telling it again. If you guys are PhD students, engineering students, scholars, and whatever, and if you want to build an autonomous drone, want to try and build an autonomous drone, you can go to the A2 list and register for free. Also go to the website and register for free as well. There's a $1 million prize pool at the end if you manage to win the autonomous race that's going to be held in April. So check out the details there. And all the kids that I see over here, if you want to get into drones, get into the multi-flying drone, build a drone, head over to the DCL group and see more about what you're going to be on that list. And you can join that as well. I'm with the API and I'm following. I just want to see how it is to fly a drone. Head over to the DCL group again. There's a simulator there that you can try out for free.
Okay. Yeah, here we have the yeah, here I think it's the present. This only for the show. I think it's finished too here. $11 is starting for that Falcon. Okay, camera one going to the Falcon. Okay. Hello. 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 सो जा. सो जा. Hello. Hello. Yeah. Can I go to Falcon? Okay then, okay. Now join. Okay then, okay. Okay. ഞാൻ ചോദിച്ചു നോക്കാം. ഹലോ. അവരിപ്പോൾ ഈ ഫോട്ടോ എടുക്കുന്ന തിരക്കിലാണ്. അവിടെ ഞങ്ങൾ റെഡിയാക്കാം. നോ പ്രോബ്ലം. ഇവിടെ മറ്റവനവിടെ ഉണ്ട് ഇവിടെ. Can I take one interview for who is win the car and you can say like this? Yeah. Okay. Who does?
Or the team? Over. I think the team can do a better job.
Okay then. Okay. Anybody who will talk them, they can to me.
Guys, I think they want to do your interview, so just put this on your t-shirt. You can have your car in the
Like that?
Yep. Stand there. Have your car in the hand. It's long.
Zrób z kamerą. Sorry.
Just check the mic. Hello.
Hello. Nie, możesz być.
Na pewno? Kamera czy zdjęcie?
Interviewing you since you won.
Yeah.
Just talk whatever you want to talk about. How was your journey to this race? What do you feel about? Maybe if you want to discuss what's your approach or something.
Yeah, like we've been participating in F1 10th competition since 2018. So this was our 7th competition. We started in 2018 in Italy, where we won. Then we proceeded to New York, where we won too. And then there was pandemic time, so obviously there was break. And after pandemic, we went to Philadelphia, and we came in second. And we noticed like that, but by that time, the level of the competition has risen dramatically. Then we went to London, where we unfortunately, due to the technical problem, did not finish. This year we went to Japan, where we secured second place, and this time we finally managed to get back on the first place on the podium. So we are very happy. Obviously, we've seen like the level of the competition has increased dramatically. So like every time we come, you need to be much faster, much better in every aspect in terms of both hardware and software and algorithms. So yeah, we are very happy. We congratulate all the teams who managed to come here and who competed with us. And we look forward to going to the next competitions.
University of Technology from Austria, and we here just finished the awesome second place at the F110s competition at IROS in Abu Dhabi. We're really proud and happy that our team really featured this great success at the competition. It was not easy, especially at the beginning, to adjust for these difficult conditions here. We really needed to optimize our algorithms, also the hardware, still fix some problems, but it was really a great journey and a great success here. And we are super proud and happy that our sponsors supported us financially and also content-wise to make this happen. And of course, our professor, Radu Grosu, at the research group at our university, really introduced this F110s format to our university, enabling this great success and a great journey to come here and go for the second place at this awesome race. Yeah.
What you see here is the F110 Sim Racing League. Much like the physical racing league that you have right now at IROS, we had the Sim Racing League finish 1 week ahead of IROS, and here what you see is the results of the teams performing. The same vehicles that race here, the 110 scale RC cars retrofitted with sensors, onboard computers to now race autonomously, are being replicated as digital twins within a virtual racetrack and racing there to now compete against the lap times, to put up the best lap times that they have so far and get the prizes for that as well. What you see here is the digital twin in action. You have got a lot of things that you can do that possibly are limited in the physical race, and that's now unlocked with the Sim Racing League. You can do more than one vehicles, you can do 10 vehicles at the same time, you can probably have more learning-based algorithms compete on the track, you can do a whole lot more. So please visit f110.org or autodriveecosystem.github.io to learn more about these things. Thank you.
Could I get one of you guys to bring me a USB-C to HDMI adapter? You're the man. Oh, you have it. Perfect. Thank you. Okay, is this thing on? Great. Okay, we're going to go ahead and kick off the award ceremony for the EU Robin Manipulation Skill Versatility Challenge right now. So if you guys want to come join us at the back of Hall 5. We have with us our teams from all over the world. We've got, go ahead and let me hear you. Where's team from China? SUS Tech, all right, great, cool. And we got another team from the Netherlands, I heard. Oh, right, we got Platonics right there. And then we also got, who am I missing? The team from Germany. RoboPig, where are you guys at? All right, cool. Thanks for making some noise, making me feel some love here on the stage. So, I just want to quickly share a little bit. I know we have the keynote at 12, so we're going to make sure you get there, but this is really important to our teams who have spent the last 30 days trying to put together a solution for us to have a really great demo, which we just saw over there in the middle of Hall 5. How can I do this carefully? Ooh. Yes. Okay, great. So, I want to say officially welcome. My name is Peter So. I'm at the Technical University of Munich, where I am part of the Work Package 1 team for the EU Robin EU project. It's a network of excellence, and we have, as a part of these outreach activities, the opportunity to organize competitions, and we're very grateful to IROS to letting us to have this great venue where we can actually, for the very first time, get our teams to compete in one location. So I want to say thank you to the IROS organizers for making that happen. I might call this the MSVC, that stands for the Manipulation Skill Versatility Challenge, because it's a lot to say. So MSVC is what our competition is for you today, and we have this really great logo that you might see on our website. Also a shout out to the MERMI for providing the robots that were able to be used for the competition today. So these are shipped from Germany. That was not an easy feat, so thank you guys at MERMI. I'm also MERMI, so thank you to me. Really quickly, I want to share a little bit about the EU Robin project, and we are also joined here by a very nice set of jury members, one of which we also have Professor Aline Abou-Shafer, who's the director of the EU Robin project with us. So I hope if I don't say anything right, please correct me. But this is an initiative. It's a 4-year-long project. It's a 32 members from universities and companies who are working together to benefit the greater robotics community by creating a central European repository for collecting robotic skills for the circular economy, for health and personal robotics at home. And this is really a great initiative that is a great network. In the EU project, it's called a network of excellence, and this allows us to really get a chance to network the top universities across Europe to work together. The next event that we have after IROS will actually be in Nancy, France, where you'll see the annual meeting of EU Robin, which is also happening at the same time or right after the Humanoids Conference. So if you're there, I really encourage you to take a look at our website. There's really great partners you can see here on the left side, a really great list of universities you might know, and you can also see we have a very impressive group. I hope this podium is not in the way, but really hundreds of roboticists working together, and even more impressively, probably the most impressive collection of robot platforms you can see around the world. So we have really impressive systems there. So please take a look at our website. You can see it here, or search EU Robin Project. Okay, now that we got this, also I want to say thank you to the EU Robin, because they are the ones who basically sponsored the competition for this event. So thank you for making that happen. So we have, as part of any competition, we want to really give some recognition. And so we have, with the help of the EU Robin, we're able to give some prizes. And so for this, we engaged with EU Robin members through our network to form an expert jury. And I will show them to you in a moment. But here we have, in our competition, we had started 2 months ago. They had 30 days to compete remotely with our task board. And they were able to take this and work at home in their own lab without the comfort, with the comfort of their own home, not the stress and anxiety of doing this live on stage. So we have lots of really great videos on our website. I want you to take a look at all the great work, but we also have the demos there that you saw just a few minutes ago. We have 3 prizes that we want to recognize the teams with. So the very first one, the task board has 6 different aspects, or 6 different subtasks in its protocol. You have to find the task board randomly placed on the table, press a button to confirm. You have to actually find a slider and manipulate this to match a value that's randomly set on a screen. You also have to pick up a multimeter probe and actually plug it into a test port, open a door, take a meter probe tip, and actually probe a terminal block behind this door, wrap up the cables, and then restore the cable and the probe to its rest, and press a stop button. And do this all within 10 minutes. Fully autonomously, no assistance. And the teams have done extraordinarily well. I want to not underplay the great things you guys have done over these last 30 days, so I really appreciate the effort there. The top team, we have 3 awards we want to give out. So the first is the fastest task board solution. This is how fast did they do those 6 things I just mentioned. And then the second is the transferability demo. So this is where we want to really highlight the second aspect of the competition is not just to solve the task board, but to also solve objects that are related to the task board. So we have what we call the BYOD, or the bring your own device, so the teams can choose an object of their choosing, ideally related to the circular economy, where they can show the skills that they learned on the task board can be applied to another object. And so this award is for the best BYOD demonstration that they showed here today at the show. And then thirdly, we have our top prize, which is crowned with $1,000, which we call the most versatile user solution, or the most versatile robot platform. And this is a bit vague, I agree, but what we want to do with our competition is not always award just the fastest or the one that is the shiniest and prettiest for that moment. What we want to do is take competitions as a way to benchmark performances regularly over time. So we do competitions year over year over year. And the idea is that we want to have solutions that it can grow. We don't want to limit you just to what you're doing this week or the month before, but we want to have you develop solutions that are actually contributing to the greater robotics community. So that's why we ask you to make your code open source to contribute to the community. And that's why we make those all available after the competition on our website. So those are the 3 prizes. And I want to just bring up my co-organizer, Abdallah, to help recognize this. So we're going to help me out. Let's give a round of applause to Abdallah Swikir. Okay, so we're going to go ahead and do the certificates now. How much time do we have? It's a little bit live. Okay, can we do the participation ones first? At the same time? Okay, so we're going to give out a certificate for participating. We really appreciate it. It's not a small effort to come. So we have 4 teams of the 7 who have applied with us today. And so I hope you guys are all here. The 4 teams who are here with us. And we're going to give a certificate for participation, and we're going to give a certificate for the prizes that we award. Okay? So let's get a big round of applause. I need some energy here, yeah? Come on, let's go, let's go. All right. Okay, so we'll start with the first award, right? Do you want to say some words before we reveal? Okay, let's do that first then. Okay, so I really want to invite, not yet awarding, but an honorific award to one team that really showed dedication throughout the event. So I want to call up Team Autonomous Go, who's joining us from Serbia. Please join us here on stage. And Abdallah will give you your certificate. And let's grab a picture if someone has a camera, right? I think we're good. Picture. Great. Okay. Thank you guys so much for being here. I really appreciate the effort. Yeah. So these guys had come through a lot of adversity coming through here, and they were able to still make it to the conference. They were unable to present something today, but we really appreciate you guys coming. Okay. So the next thing we want to do is start with our first award. And the first award will be the fastest passport solution goes to oh, the jury. Oh my goodness. So here's our jury. Let's just give a really a nice nod and a thanks to our team here. We have Dr. Noemi Yakir. We have Dr. Fares Abu Daka, Dr. Ales Ude, who couldn't join us this week, Dr. Abdallah Sukir, Dr. Alin Abu Shafer. I'm just a PhD student. I'm just helping organize. And Dr. Professor Fabio Bonsidorio. Thank you so much for your help. It's really making the caliber of our solutions and the team experience so much better that your participation is here. So I hope the next slide is with the first place, the next award. So the fastest passport solution goes to Team Design and Learning Research Group from the Southern University of Science and Technology from China. Please come join us on stage. You guys will be taking home $400 US. Thank you for your time. So these guys were competing with the UR10E, and they had this robot also at their home university, but they're using the one that we brought from TUM. So let's go ahead and get a nice picture here. I hope we got everyone's name here. Great. Thank you so much. Congratulations, everyone. Yeah, great work. I believe the fastest time, if I want to share this number, I want to get it right. So the fastest time that we saw for our task board, remember there's 6 different tasks, and so they actually completed the task board twice in the 15-minute presentation. The first run they did was 46 seconds, 0.9. Yeah, so about just under 47 seconds here live on the floor there. Maybe if you're nice, you can ask them if they do it again later in the show, who knows, but that was very fast. The second one was 47 seconds, so they're very consistently there, and they said they could actually push it even further. They actually had recorded at home, the fastest time was under 28 seconds, so 27 seconds. This was very, very impressive, and the last time we did this competition, I think the best human was 16 seconds, so we're really approaching human performance, and that's really, really, really cool, I think. So thank you guys for that effort. The next award I want to give for the best transferability solution, or I'm sorry, the best transferability demo with the BYOD devices. It goes to Team RoboPig from Germany. Thank you. Please come on up to the stage. You guys represent the Technical University of Applied Sciences at Würzburg-Schweinfurt, right? Great. Congrats. Let's take a quick photo. Do you guys have the certificate? Okay. Thank you very much. Okay, and then the final prize we want to give out today is really a little bit complicated to explain, but we call it the most versatile robot solution for the versatility challenge that we're holding. And versatility means a little bit different things to different people. We define versatility as something that's really easy to use for not just one use case, but many use cases. And so this, the jury took into account many different things: your solution on the task board, the solution on the bring your own device object that you brought, but also we brought a hidden object with us to the conference, and we challenged the teams to teach their robot to solve one of these Montessori boards for kids in the few days that they had. So each team had 4 to 6 hours during the conference with our robots to make the solution work. And this was not a small effort to take what they had at their university and making it work here. So I really want to highlight that really great effort, and really want to congratulate our next team for the most versatile robot solution for the Manipulation Skill Versatility Challenge here at IROS 2024 goes to Team Platonics from TU Delft. Come and receive your certificate and your prize. These guys were working with the Franca Robotics Panda robot, so I think that's the new name. Great guys. Congrats, guys. Yeah, really, really well deserved, I think. All right, let's get that picture, huh? All right. Congrats, guys. Do you guys want to say anything? Any words here to the audience?
We're very happy of receiving this prize, and we happy that you decided to push to do these challenges. And I mean, from the beginning we joined, we say, okay, we know that probably are not going to aim for being the fastest one, but we want to try to see if using some intelligent solution we can try to be the most versatile. And I think we hope to see more solutions going these directions, because we need more robots that can help us do more stuff. So, yeah, thank you for the possibility of joining here and train this, and yeah, we're very proud of this prize. So thank you.
Thank you. Thank you so much. I think just the last few slides here just to show. So we do have some fun while we're here. So I want to also say thank you to our photographer. Also from the team at SUS Tech, thank you for using your camera and really capturing some nice moments here. Oh, looks like my battery is going to go. But I really want to say thank you guys really from, I know a lot of you, it was difficult to get here to the conference. I know some of you also paid out of your own pocket because it wasn't able to get support. So I really appreciate that. So it means a lot. And finally, just to the organizers. So thank you guys, my colleagues at the TUM, Professor Abdallah Sukir, Professor Sami Hadadin, and also Professor Yudi Prasetio at the Middlesex University helping out here locally. This is really helpful. Could not have done it without you. Thank you so much. And if you guys have any more interest, please take a look at our website. Go ahead and take a picture of that. You can view the competition rules, the results, as well as the solutions to the teams. There's videos of their solutions and also a link to the repositories that they have shared with us. So I think it's actually really good content. You should take a look, and I would highly encourage you to follow us at EU Robin. And we look forward to seeing you at our next event in Nancy, France in the end of November. Let's do one group picture with everyone on stage. If we can do that now, that'd be really helpful. So thank you very much for your time, and that's the end of the presentation.
Okay, thank you. We're gonna have more photos later on. Okay, so let's get this over first. Okay, and then we have for best human winner and also for best overall. We have so we actually have a tie, as you guys can see. The top 3 humans all have the same points, but ultimately we look at the so when this happens, we look at the shortest aggregate time. So the best of humanity is Sushi. All right. Yeah, so anyway, if you guys can humor me for like another 5 minutes or so, I do want to say thank you properly to a lot of people that have been involved in this whole competition. So actually, there are 2 groups of people that are physically not here, but honestly, if they show up, they will outnumber all of us here. And honestly, without them, this competition definitely cannot happen. So the first group will be actually all the local hosts who've been looking after the robot, deploying them in the real world, right? I think this competition is unique because we do it in the wild, right out there in the open. But you can imagine, as we do things in the open, things are gonna fail, right? Someone need to go and charge the robot, recover the robot. And for this competition, we actually have 8 locations, but for every location that you see today, there are at least 3 or 4 more that we've been testing for the last 1+ years actually. To finally nail down to these 8 that we get to do today, right? So I really want to give thanks to all of the hosts. And actually a lot of them are robotics enthusiasts like a lot of us here, and they just do it out of love for robotics. The other group of people I really want to thank are the admin team. So again, I don't think we dare to do this unless we can keep this relatively safe. And honestly, we can only do it because we have another group of human beings who are actively monitoring all the live feeds that are happening, right? Not just for these 2 days, but for the last 1+ year as we're gathering data, right? So that's actually how we manage to keep things relatively safe and never have any like disastrous result. So, and that's another big team, so I really want to thank those guys. I also really want to thank my team from Robotics. What you guys see in these 2 days are actually 2 years of hard work from the gang, and particularly I want to really thank Niresh. Where's Niresh? Yeah, so I think he's the most stressful man his last couple of days. I think he did a great job. A lot of you have actually come to me and say that hey, things run really smoothly, but honestly there were a lot of things breaking even to the last second just now. But I think he handled it very well under pressure, so great job, Niresh. But also Sam and Luo. Actually Sam and Luo, they are the team and also the hardware team in China. And honestly, again, we won't be able to do this unless we have really cheap robots that kind of work, because otherwise, we don't have the resources to do it. The fact that we can have so many cities is because we have really cheap robots, and that's all because of the team led by Sam and Luo. So thank you to those guys. I also really want to thank May. May over there, she's usually very quiet, but she actually do a lot of the administrative, all the details, a lot of it is actually handled by her. So, thank you, May. Yeah, she's very shy, like I said. San Diego, right? Honestly, all the AI teams will know you well, right? But honestly, before you come in, like our code base is a mess, a lot of bugs, so he really got a lot of things really started working only when you come in. And of course, the SDK, every week in, week out, he's pushing out new version based on the feedback from the AI teams. So thank you so much, San Diego. And Carlo, yeah, also a lot of people, so he's the guy who's been doing the live stream. I don't know whether you guys know, like yesterday, the live stream, more than 1,000 people actually tuned in. So, and a lot of them have said that, like, where do you hire this professional commentary? So it's actually just him. And so, yeah, great job, Carlo. And actually on the front, on the marketing side, I also really want to thank Carl and Jason. So in my opinion, we are doing really cool shit, here over the last 2 days. But we really needed someone to really tell a good story about what we did, the last 2 days. And I can't think of a better person than Carl. So hopefully tell our story well. I think your audience will love what we do here. And also, I really want to thank our local competition host, Majid, Hamad, and Muhammad. Honestly, once I find out that this is going to be in Abu Dhabi, I jumped at the chance. I really want to do it because obviously I used to live here, really love Abu Dhabi. And if you don't mind me, I practiced it a little bit yesterday. Hopefully I don't butcher this. Shukran lakum ala husnil diyafatikum. Shukran lakum ala musadatikum hilalla ashur amatiyati. Atamana annafala astika. Okay, cool. Thank you. Okay, shukran. Okay. Okay. And then, of course, I also really want to thank the co-organizers of this competition. So, Jie, Tingnan, David, Joanne, Naoki, Xue, Ted, Drew, Zuo, Wenhao. Honestly, for us, when I say us, meaning we at Robotics, we are not researchers, we're not academic, we are not even robotics in the first place. But I do think that we share the same end goal as you guys. And obviously we are not as brainy as you, but the way we contribute to this space is do what we just did. So we do have a hypothesis that this is going to be useful, but honestly, without you guys coming on to co-organize this and give us this validation, we probably wouldn't have lasted until now. So I really want to thank the co-organizers who have been helping out to bring this together. Also, a very quick shout out to Exhibits. They're not here, but they provided some compute for the AI team.
Barbara, and I was starting my work at JPL Caltech. It was almost 40 years ago, so it was long ago, and he is now an emeritus professor at University of Tokyo. In 2024, Professor Nakamura joined the Mohammed bin Zayed University of Artificial Intelligence here in Abu Dhabi, where he is now professor and chair of the robotics department. Professor Nakamura's field of research are humanoid robotics, biomechanics, human digital twin, and their computational algorithms. In this area, he was a true pioneer, developing the first in-depth analysis of human motions. He received many, many international awards, among which I want to just to mention a few: the King San Fu Memorial Best Transaction Paper in 2001, the GSME Medal for Distinguished Engineers in 2019, and the Pioneer Award of the IEEE Robotics and Automation Society in 2021. He is affiliated to many scientific institutions, among which he is a member of the Academy of Engineering Science of Serbia, distinguished affiliate professor at Technische Universität of Munich, life fellow at IEEE, and fellow of the Japan Society of Mechanical Engineers. So please, welcome with me Professor Nakamura on the stage.
Well, thank you very much. Very kind introduction, Paulo. My talk today is embodiment of AI and biomechanics/neuroscience. My name is Yoshi Nakamura from MBZ UAI. So I'm an old man, and I got all degrees in before 1990s from Kyoto University. And my advisor was Professor Hanafusa, and Professor Hari Asada of MIT was a PhD student when I was there. And afterwards, I took these kind of positions, Kyoto University, University of California at Santa Barbara, and then coming to University of Tokyo, and stayed there over 30 years. And I finally retired by age in 2020, and I continued research there for a few years in the time of COVID-19. So usually the professors in Japanese universities make the final lecture at the time of retirement. But because of the COVID, I didn't have the final lecture at that time. And I'm currently moved and staying at the Mohammed bin Zayed University of Artificial Intelligence in Robotics Department. And in 2023, about a year ago, before I moved to the MBZ UAI, our ex-student insisted to have the final lecture, finally. So I'm not really keen to have final lecture because that is something like concluding my research. I still wanted to do something more. But anyway, we had the event of the final lecture, and the title of the lecture was on the common internal state of man, machine, and motions. When I look back our research before that time, probably summarized in this way. Okay, motion, of course, is a change of body in time and space. This is natural. Machine, this is a man-made body with states. So this is, of course, it's very simple. And man, this is the natural body, of course, and with more complex internal states. So the states in the case of the man-made body, that is probably we can call it the state space or state variables, whatever. Of course, there should be more state in informatics for higher complex robotic systems. In the case of man, we have more complex internal states. Of course, we have a lot of memory. Memory will be triggered by the sensations, and then the memory creates the time sequential information. That is going to be more complex state. So the machine motion, this is keywords, but if we look at deeply, maybe body, motion, internal states, this is probably a keyword. And talking about internal states, the usually man-made system has state space, which we can design and we can probably count. But for higher complex systems, like the natural bodies systems, this is more complex. And I think the internal states is the combination of those physical body-based state space plus more information states. So that is why the internal states of natural system is more complex, and we are more complex and capable of many different things. I think the artificial intelligence is looking at how to represent and handle the internal states. So not only the physical state space, and not only simple the designed information state, there are a lot more deeper and complex systems there. And I think that is a part that the body is involved and the memory is involved. So I think it's very natural that artificial intelligence is extending and going to embodiment. I think everybody knows about this, but I just wanted to emphasize. So at the MBZ UAI, we had the demonstration on Monday afternoon there, and I just showed the very simple demo of the measurement and motion analysis of the body. The Sony has a MoCopy system. This is only 6 IMU sensors, and it is programmed to attach at the head, pelvis, and wrist and ankles. So 6 are attached to those places. So we can capture the motion like this quite easily. And we send the measured data immediately after that to the cloud system and create this. Of course, this is not the Mocopi's product. We have to map Mocopi's output to our skeletal system and create this kind of motion. Oops. I don't know how to move this. Oh, okay. So we compute all the inverse dynamics and the optimization to estimate the muscle activities. This is also a very old story, but we can do it autonomously and simultaneously in the cloud system. And we can get, if motion is 10 seconds, we can upload in 30 seconds and get the result in 3 minutes. This is what we did at the demonstration. And markerless system, we also do the markerless motion capture systems research. The 4 cameras are placed here, and we can measure without any constraint, any attachment, and so on. And we can reconstruct this kind of motion. This is probably most preferable for athlete or maybe busy person, because there's 0 time for preparation. Just get into the space and measure it. Of course, we can compute the muscle activities and compute all kind of forces in the body. Okay, in this case, 10-sec motion takes 50 sec to upload because we have big image data. And for analysis, we needed 14 minutes because the image data processing is quite heavy. Okay, so in addition to those biomechanics analysis, I don't have the slide because it takes more time, but we did the neuroscientific research in addition to this. Of course, the muscles are controlled by neurons, and the allocation of neurons and connection between neuron and muscles are literally available. So our student and colleagues worked on mapping the neural systems in the spine to each of the muscles. So having this, what we can do is to inversely estimate the activity of neurons. I don't know how to use this later, but we can, based on the robotics technology, we can deeper into the neural systems. And again, in the other neural scientific research, we collaborated with a neuroscientist in Okinawa Science and Technology Institute. They simulated the Parkinson patients-like brain signals. And it's based on the supercomputers. And we received that signal and distributed to the body through that spinal neurons and see what kind of the physical behaviors are going to appear if just we directly connect to the bodies. Of course, we could see some simple but typical motion like the vibrations due to the Parkinson's disease. But that is not deeper than that. And for informatics point of view, what we were impressed and worked on is about the mathematical model of the mirror neurons. So mirror neuron, as most of you were aware, that is the regions of the brain. It's not one neuron, it's the regions of the brain.
Students at Shawarma School, please meet at Gate D near Starbucks. Calling all students from Shawarma School, please meet at Gate D near Starbucks. Thank you.
So the region is very interesting because it's being activated when monkey see the others to pick up the nuts. And also it being activated when the monkey himself pick up the nuts by his arm. So it's worked for both perception and actions. So this is very interesting because that the same neural systems is acting both ways. And probably this is the best way to connect, and the shortest way, connect the perception and actions. And of course, we speculated that this will be a good system to make the best use of the limited resource of the brain. We can use only one portion of the brain and use it for both directions. And looking at the mathematical framework, we picked up the stochastic model like hidden Markov model. This is quite simple but useful model for modeling the time sequential data. So stochastic model, of course, you can estimate the likelihood, right? Compute the likelihood. Also, for example, by using Monte Carlo method, you can create the motions. Okay, so anyway, the hidden Markov model or any stochastic system can be used for both directions. So that is how we started using hidden Markov model. Okay, so the left bottom is our student making typical motions, and we picked up 6 motions like walk, banzai, kick, squat, slow, zenkutsu, and traject. I don't know. Anyway, we picked up those motions and computed the stochastic model, and also computed the distance between the stochastic models by using the stochastic measures, which is well known. And then we can map into the space. And 6 motion or 6 points are mapped there. Oh. Sorry. Anyway, so by having that topological structure, we can observe by looking at the point. When we perceive the motion, we can make the point in the space. And we can observe how the motion is transit from one to another. So I think by having that proto-symbol space that we named, we can observe and interpret the motions symbolically. Okay, another PhD student in parallel to that work worked on making the low-dimensional model of motions. Of course, the motion of human and robot or human is high-dimensional. In the case of, say, simple humanoid robot with 20 degrees of freedom, the space is 20-dimensional at least, right? So, but we want to have very simple model of the trajectory or motions. So we decided to have nonlinear principal component analysis. And we started using the neural network. And in, I don't know, yeah. We have 3 nodes at the center, and this neural network, first half part is for perception, and last half part is for generations. And neural network is trained such that input and output are getting closer and closer. So this is what we did we presented at 2003 at ICRA. And this is like the autoencoder or most common neural network, now people call, but we used for making the lower dimensional model of the motions. And this is quite interesting. We can see each motion in that lower dimensional space. If we make the 3-dimensional space of 3 principal components, this is how the structure is made. And what is very interesting is that if we train multiple data, they are, for example, kicks are coming here, walks are coming here, slow is here, squat is here. They are classified and divided into the regions. So we can, train many data in that neural network and find out, which area of the middle state or hidden state is representing what kind of motions. Okay, this is very difficult to explain. All the time, probably I explained, but I haven't been successful to convince you. But this is a simple system. So HMM is showing the set of hidden Markov model. So if we create many motion primitives by hidden Markov model, we have this set, right? And I'm assuming, of course, humans are different and not using hidden Markov model at all, I agree. But I'm assuming there's something similar, the symbolical system to interpret the motions, understand the motions. And of course, the human using that symbolic perception system and see the behavior of others. Robot use, in this case, hidden Markov model and observe the others of behaviors. If they communicate, standing side by side, this behavior is looking at robot, or maybe robot is looking at human, something like that. And then we have the output of a hidden Markov model. That is the information how the behavior is interpreted. And this is most important. This is the shared understanding of each other. Of course, if people have same cultural background, we can understand what that means, right? So we should have some shared information about behavior. And then communication is established. And what is most mysterious is that here. So what do we do after understanding the others, right? I can understand someone, what he is doing or her is doing, she is doing. Then the question is, what should I do? Of course, that is depend on a lot of internal states. So this is mysterious. And that must be further discussed and developed. But in this paper, we made a very simple trick just to connect, shortcut this. That means that just keep the same relationship. That if your friend is friendly, let's be friendly. If he's not too friendly, maybe just go away or not being friendly. So anyway, this is not recommended, but this is a very probably simplest way to make this prototype. And talking about robot itself, robot understands the humans by using his own hidden Markov model. And of course, understand the human's behavior and create the robot himself's motion by hidden Markov model. So for robot control, what we need is this one. So in this way, we can synthesize the communication systems. This is what we were discussed in the previous papers. And this is too simple demonstration, I hope. Oh, sorry. Anyway, in 2005, there was the Aichi Expo in Aichi Prefecture, and I brought our small humanoid robot, 60 centimeter, and my student and this robot made a demonstration of playing a kind of fighting game. So robot is very small, 60 centimeter, and of course the student is human size. They cannot actually fight. So human motion is captured by motion capturing system in real time, and send to the hidden Markov model to interpret. And robot motion is created by hidden Markov model. So we made this in real time. It's very simple model. Actually, we didn't have, I think we had only 3 or 4 primitive motions, not more than that. But they played like the, thanks. So this is it. So it's like some kind of boxing. They are, fighting each other. So this is very simple, but real-time system of the perception and action using the stochastic systems. Anyway, the idea of stochastic modeling of behavior brought us many different interesting things. And Dana Kurich and Wataru Takano, they worked on the making the segmentation and classifying the segmented data in real time. And in real time, by observing the motions, we can make the this kind of classified the motion primitives, and we can even create the sequence of the hidden Markov model. And in this way, we can learn the longer behavior, not just a segment of motions. So can you click, please? Oh, anyway, this is fine. Okay, so this is a case where we use that system for predicting the future motions. The white person is a current segment. It's showing current segment of motion. And by the way, this motion is very simple. This is what we call in Japan the radio exercise. It's a sequence of exercise people do following the radio music. And the red person is one segment ahead of time, future. And the yellow person is the 2 segments ahead of time. So one segment is about 1.5 or 2 seconds. So we can predict the motions. Of course, in this case, we know the sequence, we know the segment. Using those kind of knowledge, we can predict people's motions. So by using the stochastic model and the knowledge of motion data, we can extend in many applications. And Professor Wataru Takano, he's now in Osaka University, worked on further connecting the symbol with words and languages. And we worked on this work in early 2000. Can you click, please? Oh. Oh. Sorry, I cannot click. Okay, anyway, it is very simple model. Actually, once this Sega came to our lab and asked how to use the motion capture data later for other applications. The motion capture data, they take a lot of data for particular gaming or game software, but it's never possible to reuse them. So retargeting is very difficult. And we asked what other information they have. Then they said there is some handwritten note that describing about the motions. So we thought that if we can, connect the wording of the note with the motions, what can we do? So that is our starting point. So Wataru Takano, he developed the stochastic model, finding the relationship between motion segment and sequence of wording. Of course, sequence of wording does not specifically linear to the motions. That is the fundamental problem. But we connected them. Anyway, this is a stochastic system, and we can use for interpreting the motions by the sequence of word. It's very simple word, so probably we cannot call it language, but we can make it. And on the other way around, by wording, we can create the motions. So I'm hoping at MBZUAI, I had a chance to work together closely with the people in large language model and to further develop that kind of directions. So that is the probably most important reason I decided to come to this university. Anyway, Professor Takano's work is also very interesting. I think this is suggesting how we can use the knowledge of motions to real physical systems. So we have a stochastic model about the motions. And we know the model of the physics of robot system and the object system. And usually we create a control system and design the parameters, right? So I think the natural way of using the knowledge in stochastic model for designing controller is, of course, stochastic control design. So using the Hill-Markov model, we combined the very standard model of the, let me further go. Oh. Sorry, my movie doesn't move. But anyway, so we can use the stochastic model to design the controller. That is probably the very straightforward way to use the knowledge data we develop by stochastic model for the real physical robot control. So this is the other study by our PhD student. And we started using the text data, sorry. The Ikuo Kusajima, he was a PhD student, and he tried to use more text data or document data. And we picked up what is known as the Aozora Bunko. That is a library of the copyright expired books and novels. So he collected all of them and tried to use to train the stochastic model between the motion and our wording data. Of course, the motion data is very small set, and text data is still very small as compared to the large language model. But I think having the language knowledge, I think the large language model now let all kind of text data in the world. So basically, they have all text knowledge about human life and human thinking. And the question is if we can consistently use those data in good use for interpreting and controlling the motions. That is also what I'm looking forward. Oh, it was moving. Yeah. Sorry, some are Japanese, but let me skip this. The wording is Japanese word, so sorry for that. And this is like loading the boat. And it's create a lot of the keywords, but it's not really fitting to the motions. But anyway, we can create many of these wording. And when we showed this, the most sentence created is like housewife baking by fry pan, or housewife is cooking. So from the gender point of view, this is very much biased by the text data, unfortunately. Of course, the relationship between object and motion is most important for real applications. So one of our master students made the model of connecting the object and the body. So he computed the distance between the many feature point of the body and object. Of course, the shape of object is also modeled. So we can create these kind of sentences by stochastic model. And this is what Wataru Takano worked on Toyota to apply the motion knowledge, stochastic knowledge, for controlling real robot. But let me skip. I think, so this is the, PD control model. No. This is very simple control model. This is a control law, right? Proportional feedback and force feedback. And the, all kind of the parameters are identified at the stochastic modeling. And this is the result of experiment carrying different objects than what is taught. And we can model and create the motion by the stochastic control model. Okay, so what we want to do with this? Yes, we can create motion data, we can compute and also store the muscle force or maybe neural signals we can estimate, and that will probably provide us a lot of data and knowledge about human and human sensation, human neural systems. So what do we do with this? This is probably an open question, and I cannot answer well, but I definitely think that's the way how we understand ourselves. I think by having a lot of data of behaviors and internal sensations and the language data, we have many ways to interpret our behavior and our emotions. The simple motion level or maybe the sensation level of the sensory system or maybe neural system, and also the more complex language or symbolic modeling. I don't know if that kind of system is how complex and how large are they, but definitely I think the AI is looking at the body, and the relationship of body is in that kind of the framework. Okay, so I think phenotyping of human. Phenotyping is very different word. It's the word of the genetics, and by looking at the genes, people in biology want to characterize the behaviors or physical appearance. That is a phenotype. But what we are seeing here, or maybe looking at here, is a data set of human life and human behaviors. That is probably not fully decided by genotype, of course. We have a lot of experiences, memories. They decide our behavior and emotions. So, but I think the creating the collection of the human behavior, of human sensation, and human movement, that is going to be the huge impact to our life in the future. Okay, so by looking at the phenotype, what I'm expecting to see is we can grasp the diversity of the properties of human, how diverse we are, what the differences, and also we want to see common properties of humans. What is a common property? What kind of behaviors, what kind of values we share? That is probably modeled by data. And I'm very curious about the some word like truth of cognition or goodness of ethics, beauty of aesthetics. So I think these are very fundamental common value or common properties of humans, and how they are created, that will be found from the data. And this is the famous note by Leonardo da Vinci. And I just read the article that the Paul Valery was reading this book very enthusiastically in Montpellier, visiting the city libraries. And he tried to model how the genius like Leonardo da Vinci created his activities, not based on the narrative or narration or written biography about himself, but he was looking at his Leonardo da Vinci's text and drawing, and end to end try to understand what kind of the internal state were moving inside of the Leonardo da Vinci. I think this is the central interest of ourselves. What is the creativity of ourselves, or what is the creativity of genius? And I think this can be discussed having the model of the human phenotype or behaviors. We can look at how Leonardo da Vinci moved from one project to another, and what he described by note, and so on. So having the collective information about human, we can also identify what kind of process that genius like Leonardo da Vinci followed, and that is probably showing us the mystery of creativity. That is something very, very challenging, and I'm looking forward to start working on that direction. Thank you very much.
Thank you very much, Yoshi. No, I have here, so you can stay on stage. We are a little bit tight with time because there is the award ceremony, but there is time for a couple of questions. Is there anybody willing to ask a question? Okay, please.
Professor Nakamura, thanks very much for a very interesting talk, and going back sometimes to the roots of what we now, everyone now is trying to pursue, like using big language models, large language models, and visual language action. Do you hear me?
Sorry, very hard to...
Yeah, that's already happened.
Echoing.
That works better. Yeah. Professor Nakamura, thanks very much for an interesting talk, and going back to the roots of, for now, you know, a lot of guys in robotics are talking about building these fundamental models, foundation models, and visual language action models for enabling general purpose robots, etc., etc. I have two short questions. So the first one is that, how do you think we should go deeper to the understanding of the nature of movement and perception, because sometimes we're just approximating statistically without understanding what we're actually approximating. And the second question is probably related to what you mentioned at the end, is so-called co-design of robotic systems when you also optimize both mechanical structures plus some control policies. Just to know your opinion on that, and where do you think it's moving?
Okay. it's difficult question to me. So it's the open question to me. But I think the by anatomical model or human detailed model, I think it's not in my system, of course, but I think the computer simulation of detailed human movement and the sensation at the muscle level or bone level, that can be well studied or well developed. Of course, if we spend more time for making the detailed model of specific person, that kind of, that reachable place. And I think the question is if we really need all of them. But I think that's good direction to have more precise model to get more data and use it for the detailed understanding. And for building the robot, that's probably not really useful to use a human model. Of course, the body of robot and body of human is different. So the detailed model following the curvature of the specific bonds and the connecting point between muscle and bone, they won't provide good, useful data for designing a robot. I think robot should be designed artificially to best use of the material, best use of the resource, and so on. So that is different part. However, I think the representation of robot should follow the human-like representation. The behavior, motion, or maybe even the shape. If that is following the human data, that will be probably easier for us to have good communications and to make a good estimation of each other. Okay, thank you.
Yeah, well, let's thank the speaker again, and let's move to the award ceremony.
Check.
Okay, good afternoon, everyone. Thank you for joining us at the IROS award ceremony. My name is Yasuhisa Hasegawa. I'm one of the award chair. So unfortunately, Professor Anthony Majewski, who is the chair of the award selection committee, is not able to attend today. So I'll be presiding over the half of the ceremony. Okay. It doesn't work. Sorry, it doesn't work. Quick one. Yeah, that doesn't work. Okay, so now that we would like to start the award ceremony again. Okay, as you can see, there's many award categories to present today. So that gives the tight schedule. So I would like to start without further delay. Next, please. Next, please. We would like to start with IROS Fellow. Okay, so I'd like to introduce the IROS Fellow. The presenter for this fellow is Professor Shigeki Sugano, chair of the IROS steering committee. Okay, please, next. The purpose of the IROS fellow is to recognize individuals who have demonstrated outstanding leadership and service to the IROS. Next, please. Okay, currently there are 16 IROS fellows. And this year, we are honored to welcome, next please, Professor Carlos Bagler from the Universidad Carlos III de Madrid as a new fellow. So congratulations, Professor Carlos Bagler. Please join us on stage, please. Congratulations. Okay, next please. Okay, now we move on the IROS award. The first award is the IROS Harashima Award for Innovative Technologies. Next please. So this award honors Professor Fumio Harashima, the founding honorary chair of the IROS conference, by recognizing an individual within the IROS community who had made a pioneering contribution in the field of robotics and intelligent systems. The selection committee for this award consists of the Carlos Berger, Toshio Fukuda, Torsten Korregar, Anthony Majewski, Hong Zhang, and Kevin Lynch. This year's recipient is, next please, okay. Professor Daigai Liu from University of Technology Sydney for this contribution to the field of infrastructure robotics. Unfortunately, Professor Liu could not be here today, but I believe that his representative is here to accept the award on his behalf. I guess, okay, please. please come stage. Okay, next we have a IROS Distinguished Service Award, which will be presented by Professor Shigeki Sugano. And then this award recognizes the individual who have provided outstanding service and leadership for the benefit and advancement of the IROS conference. The selection committee for this award remains the same as before. This year's recipient is Professor Yasuhisa Hirata from Tohoku University in the recognition of his distinguished service to RSJ and IEEE laws in support of IROS. Congratulations. Okay, next we have a IROS. Next one is we have a IROS Toshio Fukuda Young Professional Award, which will be presented by Professor Toshio Fukuda. Toshio Fukuda, please come on the stage. Okay, this award recognizes early career individuals who have made notable contributions that have a significant impact on the intelligent robotics and systems. The selection committee remains the same as before, and this year we have two recipients. The first recipient is Dr. Marco Tognon from India Center at Rennes University for his contribution to the field of aerial robotics. Congratulations, please forward. Next, second recipient is Professor Abhinav Barada from the University of Freiburg for his advancement in the robot learning. Congratulations. Congratulations, both of you. Thank you very much. And lastly, we'll move on the IROS Conference Award, which will be chaired by Francesca Matis Rufi. Thank you very much for your applause and congratulations to all of our awardees today. Thank you very much.
Good afternoon. It's always been the most exciting time at a conference to see who won the best conference award and also the other sponsored awards. So we have 11 different best paper awards with 45 finalist papers. It has been a very hard job for the jury panels in last 2 days to visit every talk to make a difficult choice. So let's begin this exciting moment. All right, this is a list of the technically sponsored award. I will begin presenting them one by one. So if you are the authors of these award winners, please bring the entire team to the front stage, not just the corresponding author. We want to share the excitement across all collaborators. Okay, so you know the criteria. I will not waste your time, but you know it's a very rigorous selection process, and we will proceed with the first award, which is IEEE Best Paper Award on Cognitive Robotics, sponsored by IROS. And this award will be presented by Professor Han. And the finalists are
Is he coming?
These 5 papers.
I think he's coming. No?
And let's see if we're presenters here. If Professor Choi, please come to the front stage.
Okay.
This is the certificates. All right. Okay. The winner, drum rolling, is BV car, camera radar fusion for BV map and object segmentation. Congratulations. Authors, please come forward.
Yeah, please.
Some stay here. The second sponsored award is IROS Best RoboCup Award, sponsored by the RoboCup Federation. And this is not just about RoboCup competition, just to be clear. The award presenter, Wilbur Whistle, if you're here, please come to the stage.
Nope.
Okay, we will present on his behalf. The award finalists are the following 5 papers. Take a moment, and the drum is rolling. Once again, we have our winner is Embodied AI with 2 arms, zero-shot learning, safety, and modularity. Authors, please come forward to the stage.
Congratulations. I don't know the names.
Next is the IROS Best Paper Award on Robot Mechanisms and Design, sponsored by Robotics. If the presenter is here, please come to the front stage. Okay, we will present on his behalf. Okay. The finalists are the following 4 papers. Please take a moment, recognize the authors' names, and take a guess. And jump is rolling, and the winner is Barry Flex, a robotic gripper with versatility and collision robustness for robot learning. Authors, please come to the front stage. And the next award is the IROS Best Entertainment and Amusement Paper Award, sponsored by JTCF. And the presenter, Professor Sugano, if you are here, please come to the front stage. Yeah, go ahead, use yours. The finalists are the following 4 papers. Take a pause, take a guess. Who are the winner? And the winner is Robot Synthesia, a sound and emotion-guided robot painter. Authors, please come to the front stage. And the next award is IROS Best Paper Award on Safety, Security, and Rescue Robotics in the memory of Moto Hiro Kesori, sponsored by IRSSI. And the presenter will be Professor Satoshi. If you are here, please come to the front stage. Yeah. And the finalist of this award is the following 5 papers. Authors, take a moment, recognize all the finalists, not just the winner. And the drum is rolling. The winner is Learn the Regions of Attraction for Safety Motion Primitive Transitions. Congratulations. The next award is IROS Best Paper Award on Agri Robotics, sponsored by Yama. The presenter is Professor Hisashi. If you are here, please come to the front stage. And the finalists of the papers are the following 5 papers. You recognize your name there? And you wish you'll be the winner? Now we are announcing the results. The winner is Bombed Cloud 3D, a dataset toward point cloud-based organ-level phenotyping of sugar beet plants and real field conditions. Congratulations. The authors, please come to the front stage. enjoy your moment. The next award is IROS Best Paper Award on Mobile Manipulation, sponsored by Almiron Cynics X Corporation. And the presenter is Professor Kensuke Harada. Please come to the stage. The finalists of this award are the following 5 papers. Please take a quick look to see if your names are there. And the drum is rolling. Our winners are Harmonic Mobile Manipulation. Congratulations. Authors, please come to the front stage. And the next award is IROS Best Paper Award, IROS Best Application Paper Award, sponsored by IROS. Sorry for the mouthful. It will be presented by Professor O. And the finalists of these awards are the following 5 papers. Take a moment. And the drums rolling. Our winners are PROSIP, Probabilistic Surface Interaction Primitives for Learning of Robotic Cleaning of Edges. Congratulations. And the next award is the IROS Best Paper Award for Industry Robotics Research for Applications, sponsored by Mujin Incorporated. And it will be presented by Flex von Juraski. Sorry, I butchered the last name. If you are here, please come to the front stage. Or we can present on your behalf. And the finalists of these awards are the following 5 papers. Take a moment, think who is going to be the winner. Drum is rolling, and the winner is Harnessing with Twisting, Single-Arm Deformable Linear Object Manipulation for Industry Harness Tasks. Congratulations. Authors, please come to the front stage. I guess we will have to mail the certificate to them. Yes. Okay. And now to the exciting moment, I will handle my MC role to Professor Francisca and to announce the most anticipated awards.
Thank you, Des. Thank you very much. I have the great honor of emceeing the Best Student Paper Award and the Best Conference Paper Award of IROS 2024. So let's first start with the Best Student Paper Award. First of all, a big, big thank you to the wonderful committee which was chaired by Tamim Asfour and Kaspar Althöfer, and all the other members of the jury. You did a fantastic job in being there, asking fantastic questions, and judging all the nominated papers. So thank you very much. Maybe that's a big round of applause. So, and then I welcome on stage our program chair of IROS 2024, Cecilia Laschi, to present the Best Student Paper Award. Let's have a look at the nominees. There are a few more than for some of the other awards. Have a look if you're among them. Get your heart racing. And drum roll, the winner of this year's Best Student Paper Award is millipede-inspired multi-leg magnetic soft robotics for targeted locomotion in tortuous environments. Right, and with this, we come to the highlight of the award ceremony, the Best Conference Paper Award. The committee is the same as for the Student Paper Award, so thanks again for doing this. And with this, I would like to welcome on stage Professor George Diaz as our General Chair, who will present the Best Conference Paper Award. Is George here? There you are. Perfect. Okay, so let's have a look at the nominees. We had 5 of them. Let's have a look. Are you among them? Are you the lucky winner? So the winner of IROS 2024 Best Conference Paper Award is on the modularity of elementary dynamic actions. Congratulations.
Congratulations. Congratulations. Excellent work.
Just in the middle.
Congratulations again to all the winners and also all the nominees. It's a big achievement to be nominated and to win such a great conference award. So we will continue with the IROS 2024 Reviewer Awards. And the presenter of these will be Christian.
So
is he here?
You're going to be presenting? Okay.
now introduce the new prize we decided to have 3 years ago for the paper review boards, in particular for associate editors and for, of course, reviewers. And it's a prime importance to have a very good work done at this stage in order to have a good, excellent conference with a nice paper and nice presentations. The first one, the first award is Outstanding Reviewer Award. Of course, it's a very important again. And also the Associate Editors Award, because a lot of work has to be done by these guys during several months in order to have a good decision, great decision, because the final decision is done by the Senior Program Committee. So, wait, this one? Yeah, sure. Okay. Let me, I just gave some slides, but this is not my slide, sorry for that. So I have just to give immediately the results of the decision. So for the Outstanding Reviewer Award, the winner is Sigon Pan. I don't know if it's somewhere in the room. So we have a certificate for this, but no cash. No, not in the room. Okay, so we send, of course, the certificates by email. The second one is the Outstanding Associate Editor Award finalists, which is Zachary Chavis and Steve Aim. So with these two possible candidates. And finally, the decision was to give the award to Steve Aim. Is it in the room? So if nobody is present, so it's finished for me. So I just will say thank you very much. And again, for probably a lot of you participated to the review process, and this is something which is really important for the conference.
Now, let's welcome the competition chair come to the front stage to announce the competition award winners. And this concludes the best paper and all the paper in this category award section. But the next would be the best competition. Next slide.
Hi everyone. So I will announce the awards of the competitions. My name is Pedro Lima. I'm the competition chair together with Dr. Hamad Karki and Dr. Majid Konji, which I would like to invite to come to the stage as well with me. Yeah, they are from Khalifa University and co-share the competitions, please. Okay, and I also would like to invite to the stage His Excellency Saif Al-Shamisi, Deputy Director of the General National Emergency Crisis Disaster Management Authority. He will deliver the prizes.
Recording in progress.
So, we had a total of 8 competitions. One of them was remote. We had another one partially remote. It was at Khalifa University and here, the underwater robotics. And we had a total of 36 teams and around 180 participants. I would like to thank the General Chair, Professor Jorge Diaz, and the program chair, Professor Cecilia Dashi, for the visibility they gave to competitions. I hardly believe they are really important, like an alternative way of showing approaches to common problems. And so there's even also a keynote session. So this was really great. And we have all the competitions listed there. I think one of them did not finish yet all the evaluations, so we will not present the award. And I hope all the teams are here to receive. Okay, so and without much waste of time, I will announce one by one the awards, and I call the teams to come to the stage, so please be ready. So AI Olympics with Real AI Gym, the first place winner is MC Pilco, University of Padova in Italy, and Mitsubishi ERL in Boston, USA. Okay, and the next one is the Earth Rovers Challenge. First place winner is Seoul National University team. I don't know if they are here. Yeah. Okay, the next one is the Robotic Construction Challenge, and the first place winner is Jumb Vic-Lab Zhejiang University. While they take the picture, let me say, because I forgot, and it's tremendously important, to thank a lot to the organizers of the competitions, international people, and from all the local people that were local chairs of the competitions and volunteers. Without them, this would not have happened. So please, an applause for them as well. In the EU Robin Manipulation Skill Versatility Challenge, the MES VC competition, the first place winner is Platonics from the Technical University Delft in the Netherlands. The Underwater Robotics Challenges. The first place winner is Jalpari from Manipal Academy, Dubai. F110's autonomous racing competition. The first place winner is Dzik Ultimate from Poland. There they are. In the IEEE Robotics Automation Society Quadruped Robot Challenge QRC, the first place winner is Wong Stai from Zhejiang University. There was another competition. While these first ones were selected from a set of 25 proposals, there was another competition that was organized locally with a topic very local, very interesting, which was the Falcon Monitoring Challenge, and the first place winner was RIT Dubai.
Now to present the awards for the rapid fire competition, we have Dr. Rima Shur, Chair of Inclusion and Diversity Committee, and Dr. Maysem Wahbe, the Committee Chair of the Awards and Recognition of the Empowering Diverse Voices in Robotics. In third place, we have Aisha Isai, if she can join us on stage to receive her award. In second place, we have Clément Gaspard. And in first place, we have Manali Kunte.
right, so thank you everyone for joining us during the award ceremony. We are closing this. Congratulations to all the winners again, and stay seated for the next plenary. Enjoy the rest of IROS. perfect. No, 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 here, here.
Or in the middle, if you like.
Or in the middle.
I think on the side is okay.
Thank you very much for waiting. So we start the keynote session. And welcome to the keynote session of the IROS 2024. And my name is Yuki Nagai. I am a project professor at the University of Tokyo. It's my great honor to host and moderate this very important event. And the theme of this session is AI and robotics, which is a very, very hot topic in this robotics community. And recent advances in AI has a great impact on the robotics. And also the robotics plays an important role in advancing AI, and especially through their real-world applications. So today, we will have 5 keynote speakers. Unfortunately, you can see 3 keynote speakers here. One will be online, and one more will arrive soon, I hope. Their research covers quite diverse topics, including robot learning, multimodal perception and action, and embodied systems, and even the telecommunications. So we are very much excited to learn their groundbreaking research and also having the very fruitful discussion to discuss how our robotics can also contribute to the sustainable society. So let me start with the first speaker. She will be online, and I hope the organizers can connect with her via Zoom. The first speaker is Professor Barbara Caputo. She is a full professor at Polytechnic University of Turin. And her expertise is in visual processing for scene analysis, object recognition, and human action recognitions. And she applies those techniques to the robot learning. And she also shows that how the robot can learn more autonomously and an open-ended manner so that it can also adapt to the real-world, very complex situations. So, Barbara, are you ready for giving the talk? Thank you very much for joining, and we are very happy to have you here. So please join me in welcoming Professor Barbara Caputo.
Thank you. Thank you very much. I'm so sorry. I was planning and hoping to be with you, and then I had a health problem, so I'm here. I will not talk about my research today in this 6 minutes that I have, but I want to share with you some thoughts and some ideas on what's going on in artificial intelligence and where it should go, where we as a robotics community should try to make it go to actually really crack embodied intelligence. Let me start with this. I don't know you, but it's been incredible, you know, the October the 9th and the 10th. I think I will never forget that. I have seen history of science being made in front of my eyes, because for the first time we have seen artificial intelligence winning Nobel Prizes. Of course, that's not exactly what happened. Nobel Prize for Physics, as you know, went to John Hopfield and Jeff Hinton. Then we had Nobel Prize on Chemistry the day after. Fantastic, incredible work done for predicting new proteins. But the red thread on these prizes this year was artificial intelligence. It's very difficult to argue that it's the very first time that AI plays such a big role in this. So to remind ourselves, to set the scene, what does it take to do AI? What are the key ingredients in all of this? So apart from a insanely huge amount of money, and we know that and we see that, the 3 key ingredients, the training compute in terms of petaflop of notable models, the models that we all use inside, has been growing steadily in a massive way. and it's still going. And for some years, there's been an elephant in the room of which no one really wanted to talk about this very brute force, very muscular approach to AI. He who has the most data wins, he who has the biggest computer wins. But we can't really avoid this conversation anymore. This conversation has become mainstream because resources, energy resources, are starting to get scarce. And the actual results of not making sustainable AI is starting to show, not making sustainable choices in our progress in general. Of course, I would not dare to say that global warming resides, stands only on the shoulders of AI researchers, but it is a fact that a certain type of vision of progress where resources are unlimited, it's starting to bite back. So we cannot ignore anymore the fact that very big data centers, big computational infrastructures, HPC, which are being planned as we speak, that we see on newspapers, they do have enormous energy consumptions. They need enormous resources, and they do have a very big impact in terms of global warming. What means all of this for AI? And what does it mean, all of this, for robotics? So I want to share with you, is it really the only possible way? Can't we imagine other types of AIs? Well, a stream of research is not maybe the most, it still didn't get a Nobel Prize, let me put it like this, but making AI work on much smaller devices edge AI has been around for some time. Is it just something about computing, or is it something that really goes at the core of what embodied intelligence is?
Oops. Yes.
I'm very sorry for this trouble. Can we fix the problem now, or should we move to the next speaker while fixing this problem? So she was talking about the very next overview of the AI, the development, and also how we can develop energy efficient systems for further facilitating the AI development. I hope that we can hear more about her opinions and also her own research on that topic. If it takes time to get an online, maybe we can also move to the next speaker. Can someone tell me what I should do?
Recording in progress.
Oh. So we need slides, we need techniques for fruitful discussion, fruitful communications. Okay, here you can see there are all speakers now. We started with the barber's talk. Can you show either the Zoom window or the next speaker's presentation slides? Okay, so we can have your talk now. So the next speaker is Professor Melwan Dewar, who is a professor at Khalifa University here in Abu Dhabi. And he made significant contributions to the fundamental mathematics, statistics, and information and communication sciences. And he also serves as a director of the 6Z Research Center at Khalifa University, and also have a lot of their patent, which shows that his contributions to this telecommunication work. So please join me in welcoming Professor Melwan Devar.
Thanks. Thank you for the introduction. So my name is Professor Melwan Devar. I'm going to talk quite rapidly in the 8 minutes that we have around some initiatives that we did around Telecom GPT. So I'm director of the 6G Center, and you can ask me what's the relation between AI, robotics, and 6G. You have to know that wireless communication systems have been going from generation to generation every 10 years. 2G starting with what we call mobile for voice, with one key technology that you know, which is behind that, is called GSM. 3G, which was tailored in around 2000 for mobile for data, with those dongles where you could, of course, download a massive amount of data. 4G came in around 2010, so again, 10 years after, with, of course, the capability of having a wireless ADSL experience with mobility, mostly behind the technology called LTE. This is called mobile for internet. 5G came in around 2020, although 10 years also after, although at this stage, you're not seeing the impact at the moment, but mostly tailored for what we call mobile for IoT, or mobile for things. And one thing that we're targeting for 2030 is building the infrastructure to connect intelligence. Because one of the things that you saw in the recent years was about just building one single big LLM, providing you all that capability. But what we're seeing, and you can see it already in Hugging Face, we're having millions of models which are at the moment being deployed, being also basically on Hugging Face if you download those models. And the question is, how can we connect all those models together to build an infrastructure that connects intelligence? And when you connect intelligence, or when you want to have a ChatGPT talking to a Mistral, the way they talk is fundamentally different than how we and you and me talk. Let me give you just an example that you can already do this today, even in robotics. If you want to transmit an image or a video from one point to another point, which is a very good use case for robotics, what you would do basically, you would take the video, the screenshot, you would compress it, and then you would send it basically on your data, and then decompress it basically to see the video on the other side. However, if you have an AI model on one of those robots, another AI model on the other robots, a ChatGPT to ChatGPT, what you would do is video to text. And then you will not send the data, you will just send the prompt. Because by sending the prompt, on the other side, he can reconstruct basically the video quite rapidly. So it means that in a telecommunication system or infrastructure that you build, where you have AI models which are distributed, data is not transiting anymore. What transits is just instructions, because people can basically reconstruct those things on the other side. If you want to do that, there's two caveats, which makes it, of course, very difficult. Otherwise, we would be deploying it. The first one is doing mobile edge generation at the speed of light, which means that if you connect and do the system, it would take you a bit of an hour before you generate that video. So you need a system which guarantees you basically an end-to-end latency, such as within 1 millisecond, you can regenerate the video. Doing, of course, AI inference-based at the speed of light, number of tokens, is something we're working on. Second thing also that you need to do is make sure that you can reconstruct the same understanding on both sides. And this is very important. The way we have been doing compression and reconstructing basically videos on the other side was based on perfect reconstruction. Now, if you had the chance to prompt a ChatGPT or any of the other models, if you prompt and ask a question, you get an answer. If you prompt and ask the same question 2 hours later, you'll get the same answer but not the same text. But that's sufficiently enough for you to get that understanding that you had. And when we are humans, if I ask anybody of you a question now, you'll give me an answer. I'm quite sure if I ask the question tomorrow, you'll give me the same answer, but you will not be capable of getting me the same text. Which means that we need to build some kind of what we call semantic communication, and that's what we're working at hard to build this kind of 6G infrastructure. The second thing also is, of course, that you don't want just to get information and reconstruct it. You want also the system to act. And these are called large action models, which are at the heart of building basically a system with agents, which can also go on the other step. In the last Mobile World Congress, which took place in Barcelona, we had already some of the operators announcing app-free mobile phones. Why do you need an app? App will disappear in 1 or 2 years, because what you need is just an interface, And you ask what you want and it executes. Because today when you want to book a car, or a robot wants to do an effective stuff, you download the app, then you of course plug all those details. However, in general, you just say, I want a car in 5 minutes. And then you have to have all the system being deployed. And what we're going to have is LLMs, which are going to be the future of operating systems, which are going to be installed on phones, on cars and robots, and which will have what we call large action models. And you need also for those large action models to know how you can connect all these systems together so they can discuss. Now, of course, to do this vision that I'm talking about, which is in 2030, there's 3 pillars that you have to do. The first one is working basically on these telecom foundation models that can run on small devices, either basically by quantizing, reducing the size of models by doing post-processing, or building with basically the infrastructure or the hardware constraint that you have. This is called binary neural networks, and a lot of work is being done today on how you build binary neural networks where the weights, because of the hardware constraints or the low precision AI you have, makes it difficult. The second is robots are not treating language. They're treating signals, videos. So you need multimodality. How you do, for example, an RF GPT, meaning you translate the sensors that you have, which are signals, which are not at all text, video, or other things, and then basically have an effect. So I get those electromagnetic signals and I can reconstruct the 3D imaging that you have, and building these models with the multimodality that you have with sensors or the LLM of IoT is one of the big things that need to be done. And the third one, of course, is to build up the infrastructure to let all these agents together discuss. A lot of people are working on game theoretic techniques in terms of analyzing how this behavior of all these systems, which are basically LLM-based at this stage, would work. For information, we have been working already on a model called Telecom GPT, which started with gathering all the knowledge that you can have in the telecom domain, which was released in last July and made the headlines, in which basically you have very precise information about everything you can know related to the telecom domain. And now, of course, we're fine-tuning it to have more and more knowledge which are related to the kind of telecom signals that you have. A couple of examples that I'm showing you here tells you about what it can do. It can give you any kind of information when you start interacting with it related to telecom knowledge. It's called Telecom GPT. You can, of course, analyze any type of code in your domain quite easily. For example, you say, analyze the script's contribution to telecom workflows, specifying its primary functionality, and then it gives you by detail within your domain what it does. Third thing also, you can also develop any kind of C function that you want related to your domain, and it's very important because, of course, it enhances the productivity of, based on a prompt, having the whole code design. We're also working of taking images and trying to understand basically the kind of diagnosis a system, and that's very good because you want a robot that can see something and tell immediately what are the different steps you can do. And here typically you take an image of a router and the system tells you how effectively from that image you should solve that problem based on the images you have. And I think that's quite important in the way we do stuff. I just want to mention that, of course, this is just a first step. The biggest step is adding multimodality. We have recently, of course, worked out on this, what we call RF GPT, being able to translate radio frequency signals or sensing signals into basically information that you can translate. And if you're interested, I can give you more details afterwards within my talk about how we can convert signal to image and image to signals within this realm. Thank you again for your patience and listening to me. Thank you.
Thank you, everyone, for sharing your great thought about how the GPT and also the telecom GPT can come over to the limitation of space and time here. So now we move to the next speaker. Next speaker is Professor Concepcion Alicia Monge. She is a full professor at the University of Carlos III of Madrid in Spain. And she made significant contributions to the soft robotics and assistive technologies. And she integrates the model-based approaches with artificial intelligences so that the soft robotics can also develop the new intelligences. So please welcome Professor Concepcion Alicia Monge.
Thanks so much. Thank you. Well, my talk is about soft robot control, and I would like to start introducing these keywords, right, in the presentation. Of course, the word soft, that means easy to mold, cut, compress, or fold, and not hard or firm to the touch. So if we apply this concept to robotics, we have this growing field of soft robotics, which means relying on mimicking locomotion mechanisms of soft bodies existing in nature to achieve a smooth and complex motion. So it is usual that we understand that soft robots versus hard robot have more versatility in movements and security. The type of soft robots I'm speaking about in my talk is this kind of tendon-driven soft robots. Basically, we have a soft link in the middle acted by tendons so that we can control the pose of it. So this can be challenging because of the nature of the materials constituting the links. And let's see how, in a very simple way, not relying very much on artificial intelligence, I must say, we can control these. And we can find the answer to this question, how to control this, just inverting the word soft and proposing what we call the TFOS approach, which means tendon-driven fractional order system. In just one word, what I am proposing is the use of the typical PID controller, but in this case, we generalize the orders of the derivative and the integration to any non-integer order, right? From 0 to 1. This is the standard. So finally, we would have 5 constants to tune in this type of controllers, the proportional, integral, and derivative gains, but also the orders of the derivative and the integration. So today, what I want is to demonstrate that this kind of structures is very flexible, very soft somehow, right? And with this approach, we can adapt to system uncertainties and perform very robustly. This is key. And this is, of course, very competitive versus data-driven control, right? So let's very briefly introduce a case study here. We have these kind of links. We will explain that later. But we will use it for the soft, as a soft neck or even a soft arm for the humanoid robot Theo, which is our robot in the lab. And the thing is that we are simplifying the model of the soft link extremely, because we want to a linear system just given by a transfer function. And let's see how this robust approach works, right? So very briefly introducing the soft link, what we have is a continuum in the middle, a soft link, different materials for it, right? We have 3 tendons so that we can control the pose, the orientation and inclination of the link, and each tendon is actuated by a motor. So controlling the angular position of a motor, I change the length of the tendons and I control the pose of the system. So the key thing here is that, of course, if we put loads on the tip, the dynamics is changing, right? So let's see how to face this type of approaches here. First of all, let's just simply define the 2 parameters defining the pose, which are QS, you can see that in the left image, which means the orientation angle, but also at the right, you have also the inclination angle theta p. These 2 parameters define the pose. So the first step is to simply study the inverse kinematic of the system. So from a particular pose, how could I calculate the tendon lengths so that I can control the final pose? So because of the assumption of a constant curvature when bending the soft link, and this is because of the simplicity of the design, which is key for us, right? We can easily get each of the lengths according to particular poses, right? And once we get the length, of course, we correlate the length with the angular position of each motor, so that controlling that angular position, I am controlling the pose. This is quite simple, right? So now the key thing is how to model these dynamics. Easy. We introduce a step, which means a particular inclination as an inclination step, and we measure the inclination output, right? And it happens that we can model very very simplifying the model a lot, right? We can model that dynamic using a simple first-order transfer function. In this particular case, we have taken some data from the experiments, and we have obtained that gain and that particular time constant. I agree that this is a strong simplification of the model, but let's see how the controller later is facing the problem, the control problem robustly. This is key, right? So once we have the model of what we want to control, the next question is, okay, let's then define my control constraints. And I want for my system to be robust, mainly to model uncertainties, right? And specifically, one of the key things for us is that we want the neck to be supporting some loads on the top, right? So we need, of course, this is changing the dynamics of the system. Different masses are changing the dynamics. So we want to be, or to face this problem robustly, right? Also, the position of the pulleys in my systems, right, are also affecting the dynamics. But this is something not very interesting, so let's focus on the mass. And what we have done is to test experimentally the effect of putting different masses on the link, on the top of the link. And we have observed that this is the gain of that transfer function, the one changing. So finally, to conclude this part, we would say that we want a system which is robust to gain changes, right? Because of this, what we propose is a set of specifications, control specifications in the frequency domain, which are the phase margin, the gain crossover frequency. These two somehow define the damping of the system and the speed of the system, which are crucial key, right? And this is the solution as a bow diagram. We have selected a particular speed of the system and a particular damping of the system with the phase margin. And the third constraint is related to the robustness I have defined, robustness to gain changes. So this is the third, this is the equation forcing or guaranteeing that isodamping property, which means if I change the gain, the overshoot, the phase margin will be kept constant, and then the overshoot will be kept constant, right? And this is what we do. We guarantee that the curve below, the phase curve of the system is flat around the gain crossover frequency. So if I increase the gain, you can see that going down to the phase curve, nothing changes. The phase margin keeps constant, but also it happens the same if I reduce the gain. So this property, the third property, is guaranteeing the robustness. So let's see. For instance, in this simulation case, in which I have selected three specifications as phase margin 100 degrees, crossover frequency 1 radians per second, and the robustness constraint as I have defined it. So we can see that with these set of three specifications, at least we would need a controller with 3 parameters. Our proposal here, even if it is simple, you will see how a simple controller can perform very, very correctly. We propose the fractional order PI controller. So we just simply have to tune 3 parameters, KP, KI, proportional gain, integral gain, but also the fractional order of the integrator that happens to be 0.89. Of course, we can tune these controllers with many methods. Here you have some papers. I can introduce you later to them if you are interested. But these 3 parameters allows us to get the 3 constraints. You can see the flat face of the phase curve, and this is allowing me in the time domain in closed loop to achieve a response with the same overshoot. This is robust. So just going directly to experiments, you can see how this neck on the robot chest, right, and supporting 1 kilo, this is just 14 grams, the link, right, with the fractional order PI controller, a simple controller, linear one. This very flexible material, which is the neck, can control the vertical, can control the position so that it approaches always the vertical position, right? Versus the integral version in which you can see the oscillations, okay? So in an improvement of the design, we have patented this new concept in which you can see that the tendons are inside the structure. So you can see here that applying the same techniques again, What we can achieve is again a very accurate positioning, which is for us important. These are soft robots, but we still want them to be accurately positioned, right? And you can see how they perform with and without masses on the tip, right? And just to finish, this is our new challenge. We have scaled the links so that they perform as fingers, right? 3 of them, we have this gripper, and we are now controlling the grasping of this gripper, right? But this is, now we are starting using this. So of course, just to conclude, this is simple. This is a control method based on a linear model. Of course, we can try and find more complex and accurate, let's say, models of the system, but this is a first approach, and of course we can later close another loop on the top using artificial intelligence. But this is to say that before just applying artificial intelligence, we can find out or take advantage of model-based control because it happens to work, right? This is my final conclusion. So, of course, thank you to my research group, talented people working on these results. Thank you very much.
Thank you very much, Concepcion, for sharing the very latest research achievement. I think that getting the very reliable movement using the soft robotics is very challenging, but it's very important for the emergence of the higher intelligences. Thank you very much. So let's move on to the next speaker. Our next speaker is Professor Zhang Wei Zhang. He is a professor and also the institute director of the University of Hamburg in Germany. And he made significant contributions to multimodal processing and cognitive perception and human-robot interactions. And he applies his techniques not only in the experimental setup, but also the real-world application, including the civil and the industrial practices. So please join me in welcoming Professor Zhang Wei Zhang.
Yesterday, in the interview with IROS TV, I gave my expression how IROS, from the beginning, integrate intelligent system with robotics. Also in IROS 2015 in Hamburg, we have a lot of activities to introduce the emerging of AI technology with robotics. And in this year's IROS, we see more and more workshops from the side of embodied AI and a large language model combined with robotics. Actually, 20 years ago, as a computer scientist, we started with a cross-model learning topic, and my institute is called Multi-Model Systems 20 years ago. And I, as a robotist, is very much interested in the bottleneck area of robotics that's related with robot manipulation. Imagine if we want to replace the human workers for assembly a phone. And actually, we are working with Foxconn for the iPhone assembly topic. It's very, very challenging. We know that more than half of the not automated work are realized by human hands. And how to realize a lot of challenging tasks like involving not only audio, visual, but also tactile information, for example, in this electronic assembly scenarios, or especially in the iPhone. This is the king of this problem, considering teeny size, lightweight, cluttered environment, accessibility, tool use, and considering that the components are not consistent at all. A lot of adaptivity planning need to be realized. And in our group, we are also very much interested how to collect the third dimensionality in manipulation, that is the tactile information, and how this tactile information can be collected during the human manipulation, especially by using tools. We developed a kind of double stretchable the tactile sensors and published in the IEEE access, and which is used continuously in our group to collect a lot of information for tactile manipulation. In our group, we have also several EU projects related with manipulation. One is called Handle, so several colleagues of the Handle groups are also here, and we work with Shadow Robotics together and to investigate how this kind of multi-finger hand general manipulation can be realized, like opening bottle and do the pipetting and so on and so forth. And this is actually the start of this general manipulation intelligence, but so 10 years ago, we don't have the capability of mass the computation, especially is missing of this large language model and as a foundation model for manipulation. And actually, we started to think on how to use human manipulation to teach the robot as easy as possible and to realize the robot manipulation from the human demonstration. So actually, this is also the important part for generating high-quality data for the large multimodal model for this embodied AI things. And in the manipulation part, we investigate also what kind of synergy can be used for different scenarios in manipulation, and actually synergy as a kind of different manipulation task is quite important. And actually this can be an important area how to generate scenario-based learning data. And also we started to think about two important features of human language and manipulation facilities, and start to investigate these factors also almost 20 years ago, as I was assistant professor together with Professor Knoll in Bielefeld, and we are working on a project is called the Situated Artificial Communicators, and we are using natural language and gesture to plan the robot to realize the bimanual assembly of more than 70 parts of a wooden airplane. So in this part, we actually use a lot of learning capabilities, especially for the skill learning. So in our publication, so also almost 20 years old, and we try to realize 5-layer perceptrons using supervised learning from different force and tactile sensing, visual information, and to generate the different robot motion parameters. Actually, this is the first kind of end-to-end skill learning, so in the real assembly scenarios. And these are the tasks we have been implemented with this end-to-end learning, of course, supervised, and human teach this, and then robot implement and generalize it further. And with scrolling and two-arm carrying and two-arm assembly. So also we started to consider the end-to-end learning architectures for manufacturing and manipulation. Also 20 years ago with Matthias Coy, we started one special issue about advances in robot skill learning. Actually, 20 years later, we see this end-to-end learning with the big foundation model and also with the token-based, predictive learning become a reality. So in another European project, which is called the RACE, Robustness by Autonomous Competency Enhancement, we started to investigate how the robot can learn through the interaction with the human, with the environment. We do these scenarios in restaurant services and also laboratory services. So this modular-based learning from experiences was reported also 10 years ago. And actually, today, with the learning and the availability of foundation model, we have a much better starting point. And this is a lot of manual work. And by programming the learning part to program the generalization part, which is very difficult to generalize to a large scale of general applications. But if we consider autonomous system like a humanoid, which is able to help in the household, to help also in the factory automation, and also to help with the elderly care, we need to really consider the integration of this cross-modal information learning. So from the user point of view, now if we consider the robot industries, the real market of service robot is very, very small in comparison with the car industry. So one bottleneck problem is that the coding, the robot always need to be developed for the second time by the user. The dream is that how to use little coding or even no coding to give the robot to the user. And, but for the robotic point of view, we need to realize the skill capable of human-like and beyond human-like skills. So this kind of natural development of perception learning is the way that we want to realize now with the so-called embodied AI and large multimodal model part, and considering that we start from the baby, from passive perception to interactive perception to intensive imagination and to embodied realization with robot. And in this area, we started also a large-scale collaborative robot collaboration with neuroscientists and psychologists together, which started to 2015 about cross-modal learning, and we are interested how human is doing this excellent multimodal fusion task and transfer this model to human and to robot together. And the human capability of adapt to a changing, uncertain environment, the human use attention, emotion, synergy, and redundancy. So for processing a lot of information or use inhibition and to filter out a lot of information which is not used. So for the successful application of large language model, we know that attention plays an important role. How to code the attention effectively actually create the path of the success of large language model. But later, I think emotion, synergy, and redundancy, how human brain is processing the multimodal information will create also some breakthrough in intelligent robotics. And we have some technical sensors which are very similar to humankind, like visual, auditory, somatic, sensory. We have also a lot of information which is artificial, like process sensors, sonar, range finders, brain signals, text, etc. And actually, this hybrid information fusion is one important factor how to do it successfully, and from the supervised learning to recurrent neural network learning and to the agent-based reinforcement learning. And currently, we have this multimodal learning algorithm like Transformer GPT-4, diffusion model, not only for creating film and pictures, but also creating actions through the multimodal information. So also, almost 5 years ago, we found out one method to code the visual and the textile information together. And we didn't know at that time what kind of application can be later be realized. We started with some image capturing tasks, given some image information, and this natural language description are automatically generated. But now we are in a phase that not only the text and the visual information can be jointly coded, but also really the text and another information. And we are developing such general architectures, how this multimodal information with early fusion and later fusion with some local memories can be realized for different robotic tasks. So how to use the large language model with the traditional learning and control method, which a lot of our colleagues in robotics are doing. We are thinking about this and propose a system architecture for this large multimodal model-based robot manipulation. And we believe that based on the large multimodal model, so on the sequence level, even long chain motion sequences can be automatically generated. I think later the planning of robot actions will be revolutionized and automatically realized. But on the lower level, so that's a lot of skills and which we developed continuously in the last 40 years in robotics, and a lot of control method. And these skills will be further used and in a hybrid mode. And this generalizability can be realized with continuous learning. And if we consider the human cognitive level, so the lower level, for example, the fast motor control, we use a lot of models, but the higher the cognition are, the more so dynamic the environment are, we need more multimodal information fusion. And so I draw this model, word model, and cross-modal learning together very grossly, and think about we need still a lot of time to develop a reliable and good quality word model, perhaps till 2050. In this noon, Professor Nakamura mentioned also this problem in his talk. But until that time, and we used a lot of different modalities from uni-model, bi-modality, multi-modality, and the full modality to compensate the missing of the word model. So we also tried to combine this in a very good example. We developed a human kinetic model combined with two simple cameras and reconstruct the human motion in a very effective way and transform to the humanoid. Also, the sim-to-real part can benefit a lot from this word model. Recently, we are also developing very natural dynamic walking, and we use a lot of sim-to-real method to create this really human-like walking system. And for robot manipulation in cluttered environment for transparent objects, and the model can play also a role, and Dr. Wang He will give some more deeper introduction about this in his talk. In our group, we are working on this also sim-to-real, also published in this year's ICA in Yokohama. And in this year, IROS, we have also several work, and one is about how to use the tool or affordance to estimate the 3D pose estimation. Due to the time, I will not go to details. Please join these sessions if you are interested. And these are two works about how to use this embodied AI to realize the state estimation in this IROS. And we work also with some colleagues to realize the robot GPT. Just we heard the telecom GPT. We are working on robot GPT and try to combine the planning method with the foundation model generated planning, and to increase the reliability of robot planning. So if you, in this example, if you only use foundation model, you can only realize about 20% successful rate. But with our method, we can increase this to about over 19%. This was published in the Robotic Automation Letter. So my time is running up. I just gave a very brief challenges, of course, how AI will be still further developed and for the sake of robotics, and how to enable the deployment real-time computation of large language model on terminal platforms, so-called edge multimodal AI, and how to explore the cognitive evolution, the collaboration of embodied AI in social context, achieving self-reflection, tokenization-based multimodal, complementary, and how to get enough good quality data in different sectors and build domain-specific models with scalable functions and solving the efficiency of learning complex skills. So I just give two brief examples to illustrate two challenges. One is about the data. We all know that the success for application of large language model is based on this large amount available textile data on the website, and the Llama 5 have 3 have 15 trillion tokens. But until now, the high-quality human annotation synthetic data for robot applications is only about 50 million tokens, and the real-world teleoperated data is much less. And how to generate this good quality data through synthetic generalization and teleoperation is a huge topic now in IROS and ICA. Dr. Wang will give also some his experience in this area. Together with other colleagues, we are also working on how this multimodal large language model in edge computing can be realized. And this is a paper that GPT-5 level and multi-language model on your phone can be downloaded in the archive, not published yet. And to summarize, we believe now the emergence of multimodal model with the current learning method in combination with what, from the control point of view, generated by the high-quality robot skills will be the next content of so-called embodied AI for robotics. And let's work together to generate the real-world impact. Thank you very much.
Thank you, John Wei, for sharing the many different topics you are addressing. The multimodal interaction, including the tactile, is a big challenge for robotics. But I think the recent advances of AI enables us to really integrate all together to address such a challenging topic. So our next speaker is Dr. Hu Wan, who is the associate professor at the Peking University. And he aims to develop generalizable robot skills and also the embodied multimodal large models for facilitating the general purpose robots. I think that his approach has a great potential to push the boundaries of the embodied AI. So please join me in welcoming Dr. Hu Wan.
Many thanks for the introduction, and today my talk would be focused on how to develop generalist robots. And okay, probably I need this one. Okay, so I think my talk would echo Professor Zhang's idea. Basically, generalist robots gonna be revolutionary. Such kind of robot gonna support general purpose mobile manipulation. And also it takes natural language instruction as input and can achieve zero code deployment. What would be more importantly, such robot gonna render cross-industry applications ranging from manufacture, retail, logistics, research, catering, etc. And a popular approach towards such generalist robots is gonna be vision language action model. And this is an exemplar work from Google. They built a vision, an end-to-end model that take vision and language signals as input and directly output actions. And the most recent progress comes from building this data set, OpenX embodiment. This data set won the best conference paper from Accra 2024, and it basically curate and collect the data from many universities, and in total, collect more than 1 million trajectories, mainly covering pick and place, articulated object manipulation, and other tasks. And I highly appreciate this joint effort from so many research labs and universities. But I want to raise two things. One thing is, those data sets are mainly generated or collect using teleoperation. Such teleoperation system either use whole body motion capture or this kind of like a dual arm system would be very costly because it really need human effort to collect RT1 data set. For this 130K demos, it takes 17 months from 16 people and 13 robots. What's more important is to know, how much data do we need? How long we need for teleoperation to reach the level of data that would be sufficient to build a general purpose vision language action model. So that's why, in my research, we take an alternative approach towards generalist robots. We believe, given that most of VLA models focus on pick and place, and for pick and place, do we really need real-world data? Can we purely rely on synthetic data and do sim-to-real to achieve general-purpose pick and place? So in the last few years, the recent years, we curate object assets and synthesize action label on large scale, and also study, the problem, the artifacts between sim and real in depth sensors. And our philosophy is that we're going to leverage synthetic data, which is 3D native. And such data have, distance awareness, and it's more informative for policy learning, and it's invariant under the change of color, texture, lightning, etc. That's why it would be more data efficient than pure 2D images. And also, it's definitely scalable, can be generated in large scale via graphics. And for our pipeline, we're going to split it into two stages. The first stage, we're going to leave the 2D visual information, visual input to 3D. And this is our newest work going to appear in Coral 24. It's called D23 ROMA, Disparity Diffusion-Based Depth Sensing. Here, we're going to take two left infrared and right infrared input along with the original depth input. And then this model going to output a perfect disparity, which can turn into depths. Why do we need to predict depths? Because, traditional depth sensor has problem with sensing transparent and specular objects. When sensing transparent objects, the depths easily collapse onto the ground. And specular objects, we usually encounter missing depth values. So we purely leverage synthetic data set, render using physical-based rendering, and also synthetic object asset. And here we show our result. We train on million scope synthetic data, and we directly test on real world. You can see for this specular metallic ball, we get perfect depths. And for transparent objects, we also get very good depths. Actually, our result reveal that we have less than 1 centimeter, about 0.5 centimeter errors with perfect depths. And this is a comparison with other monocular depth estimation methods, and for example, depth anything, marigold, zero depth, and our depth is the only one that's gonna be sufficient for robotic manipulation. And here we give you more visualization. Yeah, sorry. Yeah, can you click on it and play this video? Yeah. So from this multi-view observation, you can definitely feel this. On the left is the raw depth from the depth sensor. Many problems on those transparent specular objects, and on the right, our predicted depth is very good. And then the next step is go from 3D to action. This work is published in ICRA 2023 from our lab, which won the Outstanding Manipulation Paper finalist. It's called DEX GraspNet. We synthesize a million scope DEXers grasping data, and this data allow us to take 3D point cloud as input and directly predict the grasping poses. And in this year's Coral 2024, our most recent work, DEX GraspNet V2, synthesized billion-level DEXers grasp data, and it is on random clutter objects. And we, in total, render more than 1 billion DEXers grasp pose. Such data support us to train a diffusion model. Can you play this video? It basically can grasp arbitrary, unseen, transparent, and specular objects. And we believe, for parallel grippers and for such multi-fingered DEXer's hand, using this two-stage approach, we can, it actually already achieved 90-ish the success rate on unseen, unknown, novel objects grasping, and with random layout under, novel environments, under novel lighting conditions. So from this project, we also have the opportunity to explore the scaling law of data. So here, the x-axis shows the amount of synthetic data we use to train our grasping diffusion model. 1 means 1 billion. And 1 divided by 10,000 means 100K. So the success rate we see, if we only have 100K data, then on unseen object, the success rate is just 58. Only if we reach 10 million, it goes to 80-ish. Only if we go to 1 billion, it reaches the plateau. So I think the takeaway message is that although we already use 3D representation, which is more data efficient, to really generalize across different scenes, different objects, we really need a lot of data. And such amount of data may be very hard to collect through teleoperation. And based on our grasping skills, we can actually build this mid-level skill library. And a high-level, like a GPT 4.0-like model can call those skills as API to form like a general purpose pick and place system. In this IROS 2024, we present Open 6-door. Basically benchmarking open instruction 6-DOF object rearrangement. And in this work, we have many fancy demos. Just give a new task and, for example, place a piece of tissue on top of the screwdriver. Our peak skill can, generalizably grasp, extract unknown tissue. And the GPT side, they understand what tissue means, what screwdriver means, and generate the placing goal. And this system can also deal with target orientation. For example, place the bottle upright on top of the red bowl. And here we demonstrate, the awareness of target orientation. And it also supports open vocabulary, place the capybara into the metal mug. And this system basically leverage the capability of GPT 4.0 and also grounded SAM to perceive and localize objects. And then it call our generalizable grasping skills and placement skills, and also using the motion planning to generate the trajectory. Definitely, such modular-based system would have many challenges. So next step, we actually can, go beyond grasping, pick and place. Completely leveraging synthetic data, our lab actually trained many generalizable skills, from pick and place to articulated object manipulation to like a whole body control, mobile manipulation, dexterous manipulation, and also most recently, we realized deformable object manipulation, basically generalizably insert hangers into unseen shirts. And such system is purely based on synthetic data without single real-world data. And it can hang, unseen novel clothes with long or short sleeve, novel neck shape and random crimples. So we believe, exploring synthetic data gonna give us a lot of opportunities to further the skill learning. And also, we should, form probably an end-to-end system to encourage the emergent behavior. So we also explore using synthetic data to train vision language action model. Here is our recent work in RSS 2024, which is an end-to-end vision language action model for vision language navigation. In this work, our robot can actually take, language instruction and directly walk in unknown environments. And this model only takes RGB streaming input. It doesn't do mapping. It doesn't have SLAM system. It doesn't have odometry. So it walks like our human being. We do not map when we walk in a new environment. We leveraging the closed loop vision system to understand where I am in the instruction and what's gonna be the next step. And this work is trained from million-level synthetic data mixed with real-world video data. And we are going to inject further depth modality into this model so that our model would be aware of spatial relationship. This is so-called spatial intelligence. In our demo, for such a very complex instruction, our robot can walk in an unseen, novel, unmapped environments to walk straight to the closed double door, go down the hallway, enter the nearest meeting room on the right, then stop near the TV. And so at the end, I want to give my guess about generalist robot framework in the future. It's gonna based on some low-cost mobile manipulation platform, and it would have a cerebellum large model, which would be multitask, multi-skill, and it gonna consume many multitask data, and most of them would come from synthetic world, so that this model gonna be very lightweighted, and it can be called with high frequency, and later it would reach the emergence. We will have a cerebrum large model that doesn't output action, only turn a long horizon task into short horizon steps. And this system may be the future of generalist robots. And so based on the philosophy that leveraging synthetic data gonna be enough for mobile pick and place, our startup Galbot have presentation, real-world demo in booth 48. So you can place order on iPad, and our robot's gonna fetch the objects from the shelf. We believe that mobile pick and place will generate a large enough market, and this would be interesting for our people to explore. Thanks for listening.
Thank you for showing their very nice, interesting their applications which benefit from the recent advances of the AI technologies. So before going to the discussion, I'd like to quickly check whether we can have the babbler as an online. Can someone check with their, yes, Barbara. Can you hear me?
Yes, I can hear you. So I see that we are running very much out of time. So I just wanted to close my talk. I don't know if you can see my slides.
We are very sorry but we have only like 10 minutes left. So if
then it's okay. It's not, let's move to discussion. It's okay.
Okay, then let's move on to our discussion part, and then we'd like to start asking some questions, how the AI and robot can benefit from each other. Maybe the babbler, you could share your ideas and thoughts. And for example, recently we have the great advanced AI technology now, and I think that you also apply such AI technologies for robot learning. So what kind of impact, including both the positive and the negative impact, you think that the recent advances in AI have your own research?
Well, the way I see it, what we are seeing in AI, I work 50% of my time in AI, 50% in robotics. So anyway, machine learning applied to multimodal learning. And the type of progress we are seeing in computer vision, in text, is not comparable to the type of progress we are seeing in robotics. And that is because the paradigm we are using right now in computer vision cannot be really replicated in robotics. So we do not have databases for size and variety comparable to those that we have for text and for vision. And I think this calls for new approach, meaning that the type of platform, the hardware, which is the embodiment of robotics, should become part of the design of the algorithm, exactly as the most successful examples of edge machine learning are doing. You look at the hardware, the characteristics, as a boundary condition of your algorithm. We are not really doing that in robotics. So I think what we mean by embodied intelligence needs brave new ideas.
Yeah, thank you. Just Barbara mentioned that the embodiment and then their conception, you are the expert of the embodied robotics, especially the soft robotics. So what do you think about the recent advances of AI and how you can connect and also contribute to such a robot intelligence from your perspective?
Yeah, well, I think, of course, in my field, we, for instance, look for smart materials that at the same time has sensorial but also actuation capacities, right, capabilities. So artificial intelligence in that field is very important in the sense that these type of materials are difficult to characterize, right? So we need a lot of data of the dynamics of these materials, how they react until certain stimuli surrounding them and so on, right? Not just stretching them or contracting them, but temperature, humidity, these kind of things. So embodied intelligence takes advantage of this. For instance, we can approach a design in which the body of the robot at the same time is measuring or sensing and acting just as a whole, but that characterization, that model is difficult, right? And probably in that case, we can use artificial intelligence techniques to take advantage.
Yeah, thank you. And I think that everyone agree with the importance of the embodiment, but I think they're Melbourne, so your work is connecting that telecommunications and connecting the different intelligence in the different places, so it can go beyond the limitation of the space and time. So what do you think about such a role of the embodiment in the current robot intelligence, and how your technique and the knowledge can contribute to the further development of the AI technologies?
Yeah, so that's a very good question. I think, I mean, there were a lot of issues which were pointed out. The first one, of course, is I mean, for people to understand embodiment is any kind of LLM that we're building today is learning only based on text videos, and it's like putting a kid in a room and he learns only based on those books and things like that. And it's evident that basically somebody who learns only in a library, everything, there's something which is missing. And we feel it because ChatGPT will talk to you about death, but will never speak about death as somebody basically who felt it, although you died before. But let's say pain, for example, then you feel it. So there's a notion of embodying and grounding to reality, basically, those models. And of course, one way to ground those models is through censoring capability. And sensors are at the heart of how you embody those models by getting things. But doing that requires a bit of a change of how we build those models, because how you tokenize pressure, how you tokenize signals, how you tokenize all these things are totally different on how you tokenize language and how far we've been doing. And I think this is one missing point is, of course, understanding how we build those multimodality models based on sensors on which basically the kind of feedback that we get is basically based on those signals, which are not in the classical way. The second is, of course, through the interactions. And interactions are at the heart of how you embody. And one of the work that we're doing is building the infrastructure to connect these different, I would say, intelligence, because we think that it's more about collective intelligence than single individual intelligence. That's how things our system are going to be made. One point, however, which was made, which I think is very important, is whatever we build, we still rely on data. And I like, of course, the work which is building on synthetic data. But going on synthetic data, I have to mention, we've been working a lot on that. There is a big issue, even if you build on synthetic data, you need to do it very carefully in how you build those. Because if it's based on AI-generated data, typically, then there's a phenomenon which is very known, it's called model collapse. We've been analyzing this very nicely because you can't learn on AI-based data. And so there's a big issue on how you found the compromise, and a lot of people have been generating AI data based on those things, and this model collapse appears very fast, which means also that in some sense, the randomness and creativity of humans is still good in how it captures the fact that you can scale these kind of systems, because you need humans at the end, because on how it scales the system. And in this collapse has been at the heart of working nicely this synthetic data that I've been seeing here. Yeah.
Yeah, I agree with you that both their embodied and grounded experiences, and also their network, their shared, their experiences can really facilitate the development and advances of the AI technologies. And now I'd like to ask John Wei and Fu, who are working in the intersection of the AI and robotics in the real-world application. So what do you think about the current AI advancement?
Yes. Now we see a breakthrough of AI thanks to the big data and the big computing power, exponential growth in applications, currently in chatting, generating pictures, videos. But these are all the works which replace human from white-collar jobs. But to replace human with the really needed blue-collar jobs to help elderly care, to automate in the factories with using hand, and a lot of manual work. And these things needs this really the multi-model embodied foundation model, which will be also on the emerging phase. One provides the possibility to be general and to be generative. Generative in the sense not only pictures, languages, but real actions. And from the robotic point of view, we have worked so many years from control point of view, and we have very, very good collections of different high-quality skills, but they have the problem to adapt in uncertain environment to be generalized as one robot. We can do all the things together. So now we are in a fantastic phase that this two society come together and to realize the multimodal intelligence in real-world robotics as one of the flagship applications and to solve the real needs of the society.
Thank you. About who?
So I'd like to first answer the concern raised on how to generate and gather synthetic data. I mean, if the synthetic data is generated using AI, then it completely becomes a chicken and egg problem, right? So I definitely understand the situation of model collapse using synthetic data in training LLM, but in physical intelligence, when we synthesize those synthetic data, we actually based on some physical equations, and we turn action data generation problem into an energy-based search problem. And when we get those trajectories, we're going to examine them using physical simulators. This is going to filter all the unphysical trajectories. We only save those valid trajectories for training. So I believe, physical simulation is also, interdisciplinary study field. We need a lot of input from graphics. Right now, there are still a lot of artifacts and low efficient problem in physical simulation. I believe a joint effort from AI, from robotics and the graphics would further the pathway of using synthetic data to pushing the boundary of embodied AI and the general purpose robotics. And this is also one of my research objectives.
Thank you. You emphasize the importance of the data, amount of the data, and also the quality of the data. Thank you. And unfortunately, because of the time, we cannot continue the discussion. But I'd like to ask the very last questions about the robotics for sustainable development, which is the theme of this IROS conference. So Barbara, can you share your thought or view or the potential contributions to develop the sustainable society or sustainable environment? How the AI and robotics can contribute to make our world more sustainable?
I think this really links to the discussion we have been having so far. It is true, we all acknowledge that the databases we do have in the robotics community, at large, are not as large, as diverse as those that are available for text and vision. We are saying, okay, we should make them so by creating synthetic data with different methods that might make them usable for the models. I think we have to rethink how we do AI. The current AI models are redundant, are suboptimal. They are not really optimized for the type of hardware that they're using. We have enormous computing facilities which are used as farms, not as real HPC. I don't see myself anymore on the screen. I don't know if you are hearing me. So I think that robotics make AI more sustainable and a sustainable world by aiming for leaner models.
Thank you. So can you also share your thought in a very few words from Melvin?
Well, I think already the distributed nature makes it more sustainable. I mean, the fact that we're seeing today, of course, all these AI, like in super clusters being handled, I think there's been already some results quite nicely showing that the distributed nature of how you do inference, how you do training, is at the heart, basically, of making things more energy efficient in how it's built. And the way, of course, goes back to what I'm doing about connecting the systems in the best way to be able to do inference. And everybody's doing it. Even Tesla recently, I mean, in their announcement, they're now trying to build basically mobile distributed training on the cars, typically, because they saw typically that having all decentralized. And I think the robotics and the fact that we have a lot of robots distributed, things like that, are going to be part of already a digital infrastructure also for us, on which we're going to be running basically the future network of AI. And I think this is a very good point, but we need to find a good way to build that infrastructure on how you connect all these. Yeah.
Thank you.
Well,
Conception.
Just very briefly, in case of soft robotics, sustainability is like inherent to the robots, right? Because they are made of materials easy to get rid of in case we have to, get rid of the platform. But at the same time, the materials are very easily recyclable, and even they can have self-healing capabilities. So we can reutilize the materials over and over and over again. So when it comes to sustainability, this is a good point in soft robotics.
Great, thank you. And John Wei.
Yeah, I would like to emphasize the importance of interdisciplinarity in the phase of combining AI and robotics, and to realize this embodied AI robotics, we need to understand not only robot skills from control point of view, but also from the artificial intelligence point of view, how to generate the good data and how to build the real good world model by considering mechanics, biomedicals, and even materials. And this is a huge challenge. Only work interdisciplinarily, and we can solve this problem in an effective way.
So I think to build general purpose robots, we also need to consider sustainability. So my first point is going to be synthetic data would be more sustainable compared to real-world large-scale data collection. When you change robot synthetic data, it will be low cost to generate new batch of data. But for real-world data, this is going to be a problem. Another thing is we need to train a small cerebellum model instead of a very, billion parameter, a serum, like a cerebrum models. This gonna reduce the carbon exposure. So that's why I think this is going to be a sustainable path towards generalist robots.
Thank you very much. Thank you for sharing your great thought about the society. And thank you very much for joining this keynote session. And I'm sorry that we couldn't take time for receiving your questions, but I hope that you have the opportunities to directly talk with our keynote speakers. So please join me in thanking all the speakers today. Thank you so much.
Thank you. So go there.
the idea of pushing the limits of what underwater robotics can achieve. This global competition has initiated students, researchers, and innovators to design and develop robots capable of performing complex tasks in underwater environments. I want to take a moment to thank all participants for their hard work and dedication. Now it's my pleasure to introduce Anja Omar Mohammed, Underwater Robotics Challenges Project Manager, to talk.
Underwater Robotics Challenges, it's the global competition that invites students, researchers, and innovators to design and develop robots capable of performing complex tasks in underwater environments. This year, we have seen remarkable advancement, and from AI-controlled navigation system to innovative robotic designs. The participants of this challenge have shown not only technical skills, but also a passion for solving real-world issues, such as marine exploration, environmental sustainability, and industrial applications. We would like to thank our strategic partner, Khalifa University, and the official sponsor, Maqta Gateway, and our community partner, RAS UAE, for their support in elevating competition to new heights. Also, I would like to thank all participants for their hard work and dedication. Whether you are on the winner's podium or not, your achievements are testament to the future of underwater robotics. Also, I would like to thank all judges and the organizing team who brought this project to life. Thank you all.
Thanks, Engineer Omar Mohammed, for your speech. And now it's my pleasure to introduce Engineer Tariq Salah, CEO of Global Innovation Entrepreneurship Company.
Hi, everyone. I'm truly honored to be here with you in this great event, the International Conference of Intelligent Robots and Systems, IROS 2024, to celebrate this great end of the challenge in underwater robotics. The role of Global Innovation and Entrepreneurship Company as an organizer of this competition is aligned with its mission to empower innovators and enable ecosystems in deep tech across the MENA region and beyond. The aim of this challenge actually was to try to empower the transfer of high tech to the participants and to help them to formulate their ideas not only for the purpose of the competition, but to try to commercialize their innovative solutions into viable startups that could actually succeed not only locally but globally. I will not repeat the thanks for the collaboration with all the collaborators, but I think that this is a promise to build an ecosystem of collaboration with different partners to empower this competition to go even more in the next year to the next levels. I'd like to invite now Mohammed Aboud, the chairman of GIE, for his talk.
Hi everyone. Let me share with you a small story about the Underwater Robotics Challenge, because actually it was very close to my heart. I started this competition since 2011 as part of the, some of you attending the MATE ROV competition. I started this competition in Egypt in 2011, and at this time, having a competition for underwater robotics was a very strange and difficult for university students. Since the date, our team who participated in Egypt and qualified in the international finals, they got the lowest category in the competition. They were the last team. Although this, the teams came back to their country, to Egypt, and say that this is the time to work in this new kind of competitions, and we need to develop our skills not only in a competition but in the underwater robotics. In 2015, our teams who joined the competition in Albania, I remember this very well, they got the highest score in the water. They get the fifth position, which is I think aquaphoton, and the judging committee was very amazed by the quality of the robot and the design of this robot. When they came back to Egypt, I gave them fund for $1 million, 1 million Egyptian pound to start manufacturing a robot for the Suez Canal Authority. It was very difficult for them to receive the money from the government, and they struggled not with the design, but with the legal and paperwork. Now all of them working in the international companies and doing their PhD in big universities, and some of them got a patent in underwater robotics, new technology. But other teams from Egypt started to work, some of them with us here, which is Vortex, and some was made in Alexandria and Selfish. Many teams in Egypt started to develop a local school that transfers the knowledge from team to another, to another, to another. And in 2018, we got the first and the third place globally in the MATE ROV competition. And since this date, every year, the international competition waiting to see the quality of the outcome from the Egyptian competition. After that, during Corona, the competition stopped, and MATE didn't organize their competition. At this time, we decided to create our own competition, which is Underwater Robotics Challenge. And we started as a local one. Now we are celebrating with all of you. It becomes an international competition, and the launching of this competition is inside IROS. And we are not doing this competition only to recognize the talent students, but also to engage them with industry. We are doing this competition in partnership with Al-Maqta Gate, which is part of Abu Dhabi ports. And now we are developing the next edition of this competition based on real challenges coming from industry. This will be, inshallah, one of the best industry competitions. We are not looking for only teams to compete and to win an award, but to be able to solve industrial challenges. I'm so happy that all of you participate with us and you succeed to make to IROS 2024, and I hope every year to see more and more teams. And as I know, robotics is a community. It is not only teams that participate and go, but you are building a community. And I know all of you doing a local activity in your universities, schools, encouraging more students to join. So I hope to continue working with us to make this competition one of the biggest globally, focusing on industry needs. We are also working in another phase to support the outcome from this competition, to raise funds and to be one of the successful startups in this area. I was so impressed and happy when I presented yesterday to our judging committee one of the best startups that came from our competition. They won the competition in 2016, and since this date, they worked in their own prototype, and now they have a lot of customers. Also, we have another company which is trying to find their way and to build a big history, and we are going to help and support in all of this. This is why we started underwater robotics competitions in our region since 2011. Congratulations to all teams. Congratulations to all of you who made it from Poland, from Egypt, from India, from United Arab Emirates. I wish you all the success, and I hope you enjoy your time in Abu Dhabi. Thank you very much.
Please stay with us at the stage, and Engineer Tariq Salah to recognize our partners. As we celebrate the achievements of our participants, we would also like to take a moment to recognize the incredible support provided by our partners. First, we extend our heartfelt gratitude to our strategic partner, Khalifa University, for their instrumental role in hosting this year's UWR challenges. And we'd like to invite Dr. Hamid from Khalifa University to the stage. And also the next one, we extend our heartfelt gratitude to Engineer Mohammed El Shamsi from our community partner, Robotics and Automation Society, UWE.
I'm saying that in IROS stage, we already recognized the first winner. And as I said in the beginning, all of you winners, all of you deserve this recognition. And thank you very much for all effort you've done. And looking forward to see all of you again and again. And I'm sure that this competition will be more bigger and bigger with all of your support. So let's start by recognizing all the winners. It will be great to welcome you on this stage.
Best winners, we are excited to present special awards for Best Gulf Spirit. This award goes to Project AUV Manipal from Manipal Academy of Higher Education in India. Let's start with the third place team. In third place, we have AGH Marine from AGH University in Poland. And in second place, we are pleased to announce Vortex from Vortex Company, Egypt. here we have the finally champions of this year's underwater robotics challenges. Taking first place are Jalbari from Manibal Academy, Dubai. Congratulations to all the winners and the participants. Your passion, innovation, and hard work are an inspiration to all of us. We look forward to seeing you how each of you continues to push the boundaries of underwater robotics challenges. And now, I would like to invite you all to the stage to a group photo. Please, come again to a group photo.